And Space Lab Martial Ops, we have you through TDRS for about 50 minutes.
Okay, Martial Ops, we've got the rod and clear bill. And we've got the 103 people standing by. I just got a quick comment.
Stand by.
Byron, this is 103. Go ahead.
Roger, 103, Carolyn. I spun up several of the cuvettes, and it put the bubbles up to the top end, but as soon as I tried to take them out, there's so much friction there that they get distributed through the entire cuvette again, so I think I'm probably just as well off to try and shake them here and get as much of a bubble aggregation as I can, and then just put them in the spectrophotometer over.
Roger, Byron. That's a good comment. We appreciate you giving it a try. That'll help us a lot in clarity on analysis.
Okay.
And Space Lab, when you're ready to copy, we have some information on the CPAC run coming up at 2+05.
I didn't realize there was one that early. Well, I'm back at the freezers now, but if there's one at 205, I better come up and get it there, please.
Okay, we copy, Ellen, and let us know when you're ready to copy.
Ready to copy, Bill. Go ahead.
Okay, they want to run a model Foxtrot Oscar 13A, model 17. The T0 time is at 2+15. Zulu time is 340 stroke 18 colon 15 colon 00. And the exception monitoring timeline is Sierra 0 to India 00. And the PCF changes, item 969, enter. Item 10, 0, enter. We want you to inhibit. These are shutdown inhibits. Item 15, Delta Golf Papa. Item 16, inhibit. Copy.
Roger, I copy all of that, Bill. And we've got time to get that with no problem, of course, but looking up at our detailed cap, I don't see anything scheduled in the vicinity at 2 to 3 hours until 28 comes along, about 45. Am I behind somehow on a message?
These are OCRs, Owen, that are coming into the system, and there may be a few of these now and then.
Okay, then if you could, make sure we have this much notice so we can get to a keyboard or get set up for it, because we've got plenty of time this time.
Yes, and they are going to be running 20 and 19 jointly at this time.
Good.
And they're going to be dumping water at this time, Owen, so it may be particularly very interesting.
At least we could see it.
And, yeah.
See the water dump. See the water dump, but probably that's about off.
Yeah, and we want you to turn the PHO off. And they have put
Thermometer was 69.
Yeah, okay. They have put a software patch in on Experiment 20, which permits their beam to be able to operate at any attitude.
See? Good.
And we'd like to also have the MTV switch turned to inhibit. we want you to manage the tape recorder during this run, and we want you to use VITR number 2.
Okay, that's O2 analog to tape recorder 2.
That's roger that.
And Marshall Ops Space Lab, DS20 for the 103 API.
This is,
Okay, Colin, we're still getting a lot of drift on the mini spectrophotometer here. I wonder, do y'all want to go ahead and change those 4 batteries? It sort of keeps going down continuously. I'd say it starts out at a reading of like 51, and before it really slows down, it's down to about 45.
that's affirmative, Byron. Go ahead and change batteries. Thank you.
And Space Lab, you may have your shift lock button keyed. Any more? We copy. And Space Lab. Reminded, Mike. Right, Owen. We're also reminded that just before their run, they're going to need to have Row 21 opt and also the CPAC depth opt. You see we got an immediate route skip there, Mike. Is that the best we can do? I believe that's the best we can do. We had kind of hoped that Route 21 might be back in full operation, but it's pretty clear that it's not. Go ahead. Look at that string of IOs, Mike.
Yeah, we copy those, Owen. We'll look at them.
And Space Lab, we have a question from CPAC. Is their IU depth switch on or off? It turned it on a few moments ago. Okay, real good. Thank you, Owen.
And Space Lab, this is Marshall Ops. We'd like to have you turn the SWA heaters on. That's O-N. And Space Lab Marshall Ops for Owen, we've got a Route 21 problem, and it does not appear we're going to be able to operate this time, and we'd just like to back out of this and terminate.
Okay, thank you.
Yeah, the other people will be running, but O2 will not.
Okay, I'll just toss out the application, and we'll turn the IU and step off.
Okay, Owen. And we certainly appreciate you trying, and the CPAC people would like to say thanks for everything that you've done.
I have a question back there, no hurry on the answer or anything, but about the, they mentioned the other day the fact that the NGP discharges, which are only a millisecond long, I believe, apparently suppress the electron flux on experiment 19. And I wonder what the sort of delay times are. Is that consistent with the fact that the shuttle glow on tail appears to be delayed until somewhat after the thrust firing is complete?
Yeah, what a fascinating question, Owen. I think we'll have a little sort of scientific colloquium here for the next few months concerning exactly what the time delay is and how we... let me check with 19, see if I can get a quick answer.
With the CPAC, black depth left on or off.
And we want the depth off, Owen, on CPAC.
Oscar Papa. Bill, could you ask Mom if it's my imagination or is it taking longer and longer for displays to roll in? Maybe it's just my impatience there, but seems like it's getting longer from day to day.
We'll look at that, Owen. I don't have any idea. We're checking with Mom now. You may have misinterpreted my last transmission on CPAC. It may have been a little bit garbled. We want the RU depth opt. That's Oscar Papa. And we want the IU depth switch on. Oscar Nancy.
I did misunderstand that. Okay, I'll leave it to that matter.
Okay, I guess we got that garbled again. We want the IU depth off.
Hey, Bill, the way it is right now is the IU depth switch is off, and the depth itself is not. Nancy Oscar Papa, over.
Okay, we copy.
What you want, or you want me to change the depth?
Stand by. Okay, Owen, once again on OT, I think, on 02, I think we've got it, you've got it correct. We want the IU depth, Nancy Oscar Papa knopped, and the IU depth switch on the panel off.
Roger.
That sure was difficult for us.
The switch. Depth. Change batteries here. Run off the line.
Okay, we copy, Owen. And just one more thing. We do have some things for Byron you might pass up. We've got some 300 activities between hours 4 and 6 today that are in work.
Okay, Bill, I'm standing by here. Let me know a couple of minutes before you give it to me. I'm still doing the spectrophotometer readings. It takes an awful long time to get these bubbles out of the cube out here.
Yeah, we understand. We'll talk to you in an hour or two about this.
Okay.
And Space Lab, this is Marshall Ops. I've collected some answers for Owen about the transient phenomena around the orbiter from the seen by the 19 team whenever he's ready to listen.
Hey, Mike, now.
Yeah, real good, Owen. I've been talking with Klaus and a couple other guys about the basic time resolution of the 19 electrons experiment is about 10 milliseconds. And Klaus, because he steps around in energy and pitch angle, doesn't have a quick answer on the real short-term phenomena that you get when the MPD arc jet fires its cloud of plasma. But he hopes in the next few weeks to be able to really nail that down with a resolution of about 10 milliseconds. And yes, indeed, there are big effects which he sees when the neutral gas plume is launched. He's not looked in much detail into the MPD data.
Okay, I wonder if he saw anything from the interaction experiment with the VLF transmitters, over.
Okay, I don't know, but he's listening in. He may have an answer for us there.
And Space Lab, Marshall Ops, we've got an answer for Owen on the MMU delay times when he's back on the loop and ready to copy.
Ready?
Okay, what JS3 is doing is they're doing some MMU dumps from the subsystem computer, and that's just causing these slight delays in your display call-up times.
Thank you.
Space Lab, this is Marshall Ops for Owen. We have Experiment 19 standing by with, he's anxious to talk to you about your questions concerning the precipitation over VLF transmitter sites and related matters.
Go ahead, class.
Owen, this is Klaus. Owen, we had 6 runs together.
Do you hear me?
Owen, we had 6 runs
Go
together
ahead.
with the VLF transmitter. And only in the last one we see precipitation. With KV, but there is no clear-cut correlation with the 5-second modulation of the transmitter.
I can't hear you.
Okay, I was listening for additional information, so that sounds like the correlation is not very good yet, so we can talk more about it on the ground unless you have some other items, class.
No, I mean,
Certainly not a good correlation, but we see precipitation where we would not have expected it.
that's all I can say at this stage.
Okay, fine. Thank you for the preliminary report.
Also, Space Lab, this is Marshall Ops for Owen. Valentine had the additional comment that you're welcome to put his experiment into any of its many data collection modes in order to examine the moment-by-moment variations in flux, but he does request that when you're done with it, it be put back into its general purpose mode, which scans both pitch angles and all energies.
Will you be looking at more or less continuously from now on, or what is your schedule?
Let's check with class 19. You still there?
Owen, what was your question? Owen, this is 19. Space Lab, Owen, this is 19. What was your question, Owen, please?
To make sure that you would be planning to operate in automatic most of the time, so whenever we were ready to use it, we would expect to find the Experiment 19 running. Is that correct?
It's my understanding that Experiment 19 will be on for the rest of the mission until
Final switch off.
Okay, that sounds fine, Klaus, and I will switch to manual control. Modify the scanning from time to time at high latitudes, and then put it back in the general scan mode.
that is exactly what we hope to do. If you could, it would be very nice if you, during electron precipitation, could switch shortly to low sensitivity and back after about 30 seconds. This we would like to have for calibration purposes. It's very important and we haven't achieved this.
So this is required during
all precipitation events.
Low sensitivity during aurora precipitation. I presume you just don't see enough electrons at any other time to make the calibration work.
We would like to see the factor of the low sensitivity to the high sensitivity. So this would be an in-flight calibration.
that's the task orders.
I understand.
Thank you.
Owen, this is 103.
Go ahead, Carolyn.
We'd like for you to confirm for us how you left the freezers, what configuration the freezers are now in.
Sorry, I could not understand your question.
Could you confirm the configuration of the freezers?
Yes, I'm just on my way down there as you spoke, and I'll check. I presume the cue card is correct. You do want it in that configuration, don't you?
correct. We want everything transferred to freezers 1 and 2. Leave nothing in the cool down.
Okay, I'll confirm that while I'm there. All of us from today look good, and I'll make sure the configuration is correct.
Thank you very much, Owen.
Slab, you can disregard that 20A power status message.
Okay, Bill, we copy. Okay, and I'm finished with the blood work. If you're all ready to copy, I'll give you some numbers.
Real good, Byron. Carolyn's standing by, and we're ready to copy your numbers from the 103.
Okay, very good. We'll start with the hematocrit for ML2, 40 and 40. For PS2, 42 and 41. MS1, Bob Parker, 48 and 48. And PS1 Wolf, 46 and 45. How copy, over?
All right, I got that. Thank you, Byron.
Sorry, say again, Carol?
That was good. I copied that. Thank you.
Okay, if you're ready for the hemoglobin.
Yes. Go ahead.
Okay, well, we made a couple of false starts and put the new batteries in and it seemed to help. So I'll start with my checklist reading number 1, which is the reference. I'll read up to 6, and then I'll read 11 back through 16. So, item number 1, 37.6. Item number 2, 101.6. Item 3, 55.1. Item 4, 45.2. Item 5, 49.6. Item 6, 50.6. Item 11, which is PS1 again, 54.0. Item 12, 44.0. Item 13, 47.4. Item 14, 50.0. Item 15, 907.7. Item 16, 35.5. Now copy, over.
I copied those, Byron. Very good. Thank you.
Okay, you're welcome. And it took a while. I think I was pretty positive that I was able to get the bubbles up to the top of the cuvette today. But that is good. So variability in the readings, but that's what they are.
We copy that. We appreciate you giving that a try. The entire blood team thanks you and Owen for your hard work on this.
Okay, very good. You're sure welcome, and I'm about to transfer the ambulance forward to the mid-deck now.
Super. Thanks much. We'll see you in California.
Okay, sounds good. Be out of the module sec, Mike.
And Space Lab, we'll see you through Aurora Valley at about 2 plus 48.
What's there?
And Space Lab Marshal Ops, we have you for about 3 minutes through Aurora.
Is it all 3 minutes there? Can you relay a message to Carolyn on the 103, please?
Certainly, she is enabled.
Just to tell her that we've transferred all the stuff to the one freezer, but I also transferred everything out of the cool-down freezer into the second freezer, and counted up the samples. Didn't count the samples in what was in the cool-down. I assumed that one was correct. We've got the right number in the blue freezer, and it looks like it's all configured for home.
Okay, that's great news, Owen. And Carolyn didn't copy. We'll pass that on. We do have one quick question for you. When you ran the centrifuge, did you get an imbalance light?
It stopped at 7 minutes, even without the imbalance light. Don't know why it stopped, but I just restarted it. We got about 8 minutes on it, and it ran fine the next time.
Okay, we copy that. And on the 28 run that you have coming up, we hope that you'll run that as you have been with both of you as subjects.
That's what we plan to do.
Okay, we copy.
We rather have a long lunch break from about 3:20 to 7:20 on our PCAP. We thought French cuisine from Marseille might be on the menu.
Okay, we've got that filled up with, sorry to tell you about this, with some fluid physics work from about 4 to 6.
Okay, that sounds good, Bill.
In fact, the FPM is pretty much yours for the day. We have blocked out some time, and of course you guys are welcome to do whatever experiments you want. But between the hours of at least 4 and 6, we will have John Pad A standing by with some suggestions of experiments you might want to do, one of you.
And we have you here for a little bit less than 30 seconds, and we'll see you at Awari at 3+07. And Space Lab Marshal Ops, we have you for a quick one through Hawaii.
No, we're middle of 20 days right now.
Okay, and we will have real-time video when we come up the AOS on Hedrus at about 3+16.
Okay.
And Space Lab Marshal Ops, we've got you for 48 minutes through Hedrus.
Okay, Bill, we got you. And you got...
And we're dropping in and out here. Hopefully you'll copy this. We've got live TV from the payload bay, and we're going to be coming inside and visiting with you for a while.
Okay, that's fine. We got camera number, I don't know. Camera number 2 is set up down here. Camera 1 is set up with a little fluid physics impromptu experiment, so you guys can switch back and forth at your leisure in here.
Okay, we copy.
Real good, Byron.
And Space Lab, are you recording something on VITR1? And Space Lab, we've lost temporarily. Downlink lock. We'll be with you in a moment.
top, Space Lab. You guys have any live TV yet?
We're still live outside, Byron. We should be inside momentarily.
And Byron, we
Okay,
noticed.
if you want to get into Blisto.
Byron, we also noticed that you're recording camera 1 on VITR number 1. I guess you're getting some FPM data. Is that right?
Well, yeah, you can take a look at it. I'd prefer you come inside the camera 2 first, though, because we got Owen doing the Blisto cardiography now.
Okay, real good.
And we've got you live inside the module.
Okay, sounds good. You're about to see Owen do his exercises. And you might want to switch back and forth to see the other camera. Interesting shape there.
Okay, we copy.
Okay, we're in our 3-minute exercise period now for experiment 028, the electroballistic cardiography experiment, and then we're going to have Owen be free floating again in the module while he does some breath holding, some free floating, and then some isometric exercise.
Okay, we copy, Byron. Okay, and we're...
And Marshall, be advised,
Go ahead,
for the MSCR people, the 300 people, I don't know if you can hear it, but the pump is sounding pretty bad.
What sounds bad, Byron?
I think it's pump number 2 on the material science double rack.
Okay, we copy that pump number 2 is making a little bit of noise.
Excuse me, it's my fault. Pump number 1 is the one that sounds pretty bad.
Okay, pump number 1.
You guys getting any of the fluid bubble experiment down there?
And we are seeing the bubble.
Okay.
And we've seen a stop on the MHF.
That's it too, 320.
Okay, we copy stop number 320. Yeah, we have that, Byron.
Affirmative, Mike. Okay. Okay, we're going back to having Owen free float now, so you guys can do what you like with a tube.
Thanks for the little show of the liquid physics there. We're going to switch cameras back over to TV number 2, which is an interior view of Space Lab.
Owen is now free floating for a minute, and then he'll be doing his last breath holding and isometric exercise.
And we copy that, Byron. Thank you.
Okay. Okay, we have a 15-second breath holding. Okay, relax. Next one will be isometrics. Cross your legs, please. And ready, mark.
Okay, we copy.
Breathing, and now and now I'd like you to crouch for 30 seconds. and hold breath. Okay, and that marks the end of experiment 028.
Okay, and we copy, Byron.
And as you probably noticed for the experiment 28 PIs, we had run out of your electrodes, so we used some the small silver chloride lake electrodes that are used by experiment 104.
Okay, Byron, thank you for that piece of information.
Space Lab, this is XO28.
Roger, go ahead.
First of all acknowledgements over how good you were, and which heart rate did you get after exercise?
It's only an estimate, but just pulling with the arms, not the largest muscles, I don't think the heart rate went above 80 or 85. Probably not even as high as it does on the ground, over.
And did you need to switch to spare batteries up to now?
I think we've changed batteries since the experiments have started.
Okay. Do you have enough tape for another run before the end of the flight?
I would suggest it's fairly marginal on another that's getting near the end.
Do you have another? I don't understand.
Like there's probably not enough tape for another run.
Okay, copy. Thank you very much.
And Space Lab, we're getting a a view of the pallet at this time.
Roger.
And we've lost KU band, and maybe we'll see you again this pass.
Okay, and I'll be standing by for the fluid physics module investigators next time we get you. Or do we still have voice for a while?
Oh, yeah, we still have voice for 30 minutes, and we'll have some additional TV in about 20 minutes, and we can turn over the fluid physics module people to you as soon as you're ready to copy.
Okay, stand by a sec. Let me get my notebook here.
Okay, we copy.
Okay, Marshal Ops, Space Labs, the BS2 here, ready to copy for the FTM people.
Okay, Byron, we have John Paday here for you.
Hello, Byron. John Paday here. The procedures for the FPM long experiment coming up are really
An optional and depend
very much on whether you are able to make the special end plate
with the
stuck on 330mm disc
from Mike Haynes'
experiment. Have you copied?
Roger, copy, go ahead.
Okay. Now,
if that
end plate works, Isidoro will come on the loop
and try to
make a cylinder
of 30mm diameter,
and then he will do some
experiments with that
cylinder. If the end
plate does not work,
then you are to proceed to
329C
with me running the experiment.
Now,
The detailed procedure are as follows.
first install
My special end plate, 329 end.
rear end plate.
Then install
The new
Wolf and I were talking about it.
I'm copying. Have
Have you any comments to make on this special end plate, which you are trying to glue together?
I'm sorry, say again, please.
Sorry, I didn't hear.
Roger, I said Rolf and I have talked a little bit, and we're a little confused. Maybe you could explain to me one more time how you and Mike and the others envision us putting the equipment together, over.
Well, essentially, we were hoping that Mike's end plate, the one for 339, could be removed and stuck on the 40mm feed plate, mounted concentrically. If this is not possible,
Go ahead, John. You can stop there. I heard all you said.
okay. Now, if the end plate does not work, then install 329 front feed plate and proceed with 329C.
Okay, Roger, I copy that. Understand.
Further instructions are, we hope very much you can accommodate Isidoro's run, but if not, then there are further changes to procedure 329C.
Okay, understand. Well, I'll get to work and start setting up the equipment unless there's something else that's going on here. I need to take a look at the flight plans.
Okay, but just one last piece of instruction. If you set up 329C, it is essential that point S, sugar, 3, is omitted.
Understand. Omit
And the feeding of liquid onto the end plate is done as before.
I understand.
Furthermore, don't proceed beyond step B or LOS, if we are LOS.
Okay, I copy all that. And I don't know if y'all can hear the pump, but I think pump 1 is about to die momentarily here.
I'll be with you later. Thank you, Byron.
Okay, very good. Thank you, John. Marshall, Space Lab.
Yeah, go ahead, Space Lab. This is Marshall Ops.
Hey, Mike, for the MSCR Systems folks, this pump is really sounding bad, and we think we may want to do a pump 1 interrupt and get over to pump 2. What do y'all think?
Yeah, I was just anticipating your thoughts there and was talking to Mel Brooks about that. He says that even though it may sound pretty bad, he doesn't want you to change over quite yet. Although we can't hear it very clearly, we'll get back to you on that. It may be a good idea soon.
Oh, Roger, okay.
And Space Lab, this is Marshall Ops. Is it a high-pitched squealing sound which we hear interfering with your voice comm?
It's pump 1 is done. It just died, and pump 2 is on and running.
Okay, we copy that.
Sounds a little quieter up there, Byron.
Okay?
Yeah, it sounds much quieter now.
You're not kidding. We can almost hear you again.
And Space Lab, we have live TV from the bulkhead, and we'll be coming inside in just a moment.
Okay, well, don't hurry.
And Space Lab, we've got you on live TV. Oops, don't find anybody home.
Right there. Still got us on TV, Bill?
And could you give us some status on 300 and tell us where the mirror heating facility is?
Okay, yeah, it's stopped, and you want to know the position of the furnace, or all the lights are out. We got that 320 stop a while back.
Yeah, it's the position that we need, Byron.
Stand by one. And did you guys have the TV on a minute ago? Did you see my entrance?
That was spectacular.
Bill, it's near the bottom of its travel.
Okay, we copy near the bottom of the travel. And how's that other pump sounding?
Sounds pretty rough, but I think it'll run for a while.
Okay, we copy that.
And Byron, we've just had Lee on the phone, and she said you've always been very good at fixing things, and she expects you can take care of whatever repairs that pump might need.
Well, thank you, Mike. Yeah, I wish we could do something about it. I think this one's time for the Maytag repair person.
Okay, we copy.
And I didn't know you guys were going to come back so soon. I was just going to grab a little bite to eat here, but I'll get back to work.
Real good, Byron. Take your time. We got plenty of time today, and if you want to knock off, take a break, your call whenever you like.
Okay, well, maybe we'll show you how we eat here. While we're talking, if the FPM people are around, I looked at Mike Faday's syringe for 339er, and I'm going to go ahead and try and set it up. The problem is that the portion with the hole in it has threads and the little O-ring seal on it. I've taken the O-ring out, and I'm not sure just what's going to happen when we try and push fluid out over those indentations and the threads and what have you, but we'll give it a whirl.
Okay, real good. Let's hope that O-ring does a reasonable job of sealing.
And martial ops, Space Lab here for Mike.
Yeah, Byron, we have a message from your Capcom. I'd like a word with you for a minute, and I'll come back. Space Lab, Houston.
Roger, go ahead, Houston.
Roger, Byron. Just a reminder to you, when the metric camera is not in use, we'd like you to close the outer cover and turn off the heaters. When you get ready to use the camera, you can go ahead and reactivate those two things. Over.
Okay, we copy. We've got the cover closed now. It's not locked, but it is closed. And let's see, the heater is in auto heat.
Okay, Byron, we copy. Thanks a lot.
Is that good enough, Brian, or do you guys want to close and locked and the heater off?
It's good enough to have the cover closed and the heaters off.
Okay, good. Heater's off.
Okay, we'll turn the loop back to martial ops. Thank you.
Okay, sure.
Okay, Okay, Byron, we're back with you again.
Okay, very good, Mike. I was just going to check and see where Lee is these days. Did you make it to California yet?
You bet. We got a phone call from her yesterday. She had arrived in Malibu and had a busy day planned in the Los Angeles area, and she's still there today, and I believe it's tomorrow morning that she'll be heading on up into the high desert country of vicinity of Edwards.
Okay, sounds good. Everybody okay?
Yeah, she and the kids are having a terrific time. She told us about some of her activities in the last day or so.
That's excellent. I'm glad to hear that. Well, we're having a good time up here.
Now, that's good. Also, we've been talking to Birgit. She came by the POCC for a day and had an enjoyable time, and she also is heading out to California.
Excellent. I think Ulf's going to bed. I'm sure he'll be glad to hear that. Okay, we're in the process now of installing John Paday's rear end plate on the fluid physics module, and then I'll try and get this front plate here on the portion of Mike Haynes' experiment onto the front plate.
Okay, Byron, we copy. We're continuing to get live video of the module interior.
Live video is nice to have, yeah?
And we've just lost our live video. Of course, we're continuing S-band for a while.
Okay.
And we've got you for about 10 more seconds, and we'll see you at Guam at 4+29.
Roger, copy. See you then. I should have something to report by then.
Okay, great, and the PIs are waiting.
Iron 331 PI.
Oh, yes. Good afternoon, Isidoro. 3
Because it seems after your comment that the traces are more visible.
Your box, extension box, and it seems to stick quite fine. I've got fluid all the way up through the perspex, and I'm about to establish a 0 point now.
And we have you for 45 seconds, and we'll see at 4 plus 48 with through S-band.
Okay.
And Space Lab Marshal Ops, we have you for about 48 minutes through S-band. And Space Lab Marshal Ops, we have live TV from the module. And Space Lab Marshal Ops, how copy? And Space Lab, this is Marshall Ops. We've got you on the S-band for about 43 minutes.
Okay, Roger, Marshall Ops, we copy, and we just now got a route skip 11 message. I guess we'll let you guys take care of that down there.
Okay, we copy RAL skip 11.
That's firm. And I've got some good news for the fluid physics module PIs.
Okay, they're standing by, Byron, and we will acquire live TV when you let us know it's okay.
Okay, you can turn it on.
And we'd like to have you op RAL 11.
RAL 11. Okay, looks like it took. I don't see an error message. Okay, and I'm ready to go ahead and talk with the fluid physics module PIs a little bit, if I could.
Go ahead, Byron. You might tell Owen that we're going to try to get in a CPAC run if he can come down to the module.
Okay, I think we just lost you. You said get him a CPAC run and stop. Okay, Bill.
It's going to be at about 5 plus 10, Owen. We've got a run for you.
Marshall Ops, Space Lab, Eddie Reed, over.
We copy you, Byron. How us?
Okay, well, you're right in the middle of saying something about CPAC, and it sounded like you dropped out, so I thought we lost you for a little bit.
Yeah, you're broken, and I'm not sure how our transmission is going to hold. Tell Owen we want to run everything on CPAC just like the previous run, and we'll give you a new GMT. How copy?
Okay, we copied that loud and clear.
Okay, we're not having much luck on your comm. Just let us know if you copy the new GMT time of 340. Stroke 21:00:00. And Space Lab, this is Marshall Ops. How copy? And Space Lab, Marshall Ops. How copy? Space Lab, this is Marshall Ops. How copy?
I'm clear, Bill. How do you read me?
Okay, Owen. Let us give you a GMT time of day 340, hour 21 minutes, and 10 seconds. Correction. 21 minutes, correction. 21 hours, 10 seconds.
Try one more time since it's just exactly that time right now. You got 21:10, Owen. Or 10 minutes. Yeah, 10 minutes.
And your T0 is at day 8:05:10 MET.
Well, that's less than 10 minutes from now. There's no way to get it set up that fast.
Okay, we're sorry. We just got the message. Okay, Owen, let's have you slip those times by 5 minutes.
Yeah, give it.
And Space Lab Marshal Ops to Owen, let's back out of this CPAC run. The Route 21 has given us some problems.
You done that, Bill? Backed out a few minutes ago after accumulating something over 68 messages, mostly relative to RAL 05 messages, however.
Yeah, we can see the I.O. messages and the Dep 5. Yeah, that RAL is just running a little bit warm. And I think that's close
messages, and there's a RAL.
Yeah, we copy.
Long since been lost from a false summary page.
Yeah, we copy all those I.O.s.
Those in Dep 05 is probably unrelated to the thing that filled up the false summary page here.
Yeah, that just disregard that Dep 05. Yeah, we were trying to reinitialize the link.
And Space Lab, this is Marshal Operations for either you guys when you have a minute or two free.
Mike? Mike?
I got part of a transmission.
Go ahead if you had a message for us.
Yes, I do. The message is that because of the recurrent noises in the pumps of the instrument cooling system of the MSDR, we're going to terminate operations on the furnaces of the MSDR, and I have a shutdown procedure for MHF and VGS, which we can carry out any time that you have 5 or 10 minutes free, or I can read it to you and you can carry it out in LOS.
Stand by a moment. You just go ahead and I'll do it here, Mike.
Yeah, okay. The first thing is the MHF reached its bottom position, that is, has traveled to the bottom of its usual range of travel?
Yeah, there's no drive, and it looks like it's very close. It's maybe a very short distance from the bottom.
Yeah, okay. That means it's completed. It's normal shutdown. You see, it reached a stop number 3-20 when the water temperature in its coolant loop rose to a 45 C limit. And so it put itself to bed. And that's the condition in which we also believe it to be. The steps which we'd like you to do are the the MHF shutdown steps, which you find on page Foxtrot 400-36. The step numbers are 9.4 through 9.10.
Okay, I'll do that.
Space Lab Marshal Ops for Owen.
Mike?
Yeah. If there's any doubt in your mind if the furnace has reached the bottom of its travel, where just rotating the hand wheel will lock it against the stop, what you can do is do a start MHF enter and a halt MHF 3-1 enter, which will electrically drive it all the way to the bottom.
You cut out there, Mike. Would you say again, start MHF enter, then what else?
Yeah, start MHF enter and then halt MHF 3-1 enter.
Okay, I'll just try that, but it looks like it's pretty close.
Okay, thanks a lot, Owen. That just makes sure.
Marshal Ops, Space Lab, PS2 here, Mike.
Yeah, go ahead, Byron.
Roger. We've got the 5 centisoke with tracer fluid into the FPM, and I'm standing by to chat with the fluid physics module. PIs here.
Okay, they are enabled, Byron. They can talk to you.
Byron 331 PI.
Okay, 331 PI, Space Lab here. We've been able to make a nice cylinder with the 100 centisoke tracer, so I removed it, and I have the 5 centisoke tracer in now, and I guess... Am I? Okay, and I'm all set up now, and I'm ready to go. So any ideas you have, Isadora, I'll be more than happy to take. Would you like to make a cylinder first?
Well, the procedure is to try the nominal procedure of 331, and the only thing is that you will need some changes in the figures. The main figure to retain, just either copy or keep in your mind, is the relationship between reservoir positions and front plate positions for cylinders with these 30 millimeter end plates, and this is roughly 0.9. So for cylindrical zones, you just enter any reservoir position and any front plate position, and the reservoir should read the same figure multiplied by 0.9. Did you copy?
Okay, I understand. Multiply by 0.9er.
Roger. Then
Okay.
the procedure is to create a drop, then to attach it to the front, to the rear plate, and establish a cylindrical zone, and go from point B to point C. That's to make a long cylindrical zone up to, say, 80 millimeters in length.
Okay, I understand. Up to 80. We'll see what we can do.
And we've got you on live
I have
video.
your... Okay, I have the 331 Bravo film magazine, which has about 1,200, 1,200 frames of film left.
Okay, well, for me, don't worry about the film.
Okay.
Okay, Space Lab, we're getting live video again from the module interior.
Okay, Mike. Okay, well, the fluid spilled over the metal disc, the opposite end plate disc, so I'm going to take a look again and try and clean it up and start over again.
Yeah, we copy, Byron. Thanks.
Byron, this is 331 PI.
All right, you go ahead, Isadora.
If I well understood, the liquid creep over the feeding plate.
That's affirmative. We're going to attempt to make contact here again.
When you used the 100 centistocks before, how far did you went? What long the cylinder was?
I was just beginning to form the zone, and I was trying to grow a 30 millimeter long zone, so I put 30, 27, and I'm not sure the relationship of the speeds here to try and grow a cylinder, so I think I'll start out growing something that's a little convex, or concave, excuse me.
Okay, well, the point is that if you feel that you cannot create a cylindrical zone, you should take into account that this is a combined experiment, and in order not to waste too much time, if you really feel there is no way out with this cylindrical growing, then I will pass you to Mike Haynes to direct another trial for Madame Rodot.
Okay, well, we'll just give it some more time here.
Okay.
Okay, your shutdown's complete on the MHF.
Real good, Owen. We copy that you've done the MHF shutdown. There are some other steps involving shutting down, let me see, the VGS, the vacuum gas system, which we'd like you to do. You can do it now or any time that you have the time. That's page 900-1, steps 1.1 through 1.5.
Yeah, I'll do that as soon as I can drift to one side of the spacecraft there.
Or if you like, I can just read you the steps. It's not very complicated.
Okay.
And Space Lab, this is Marshal Ops for Owen. Could you please read us the status of the lamps on the ICS panel? That's the instrument cooling system at the bottom. Okay, up to the CCO is also good.
Press high is off, pump 1 is on, volt is lit, and pump 2 on is lit.
Okay, thank you very much.
Lights at the bottom.
Okay, thank you very much. And Owen, could you go down to the ICS panel at the bottom of the MSDR and tell us which lamps are on there? We're just not flowing data is all, and the 300 team wants to know this shutdown status. Thank you very much.
Okay, and break Marshal Ops Space Lab here. We're going out to a 13 millimeter long standby. S bus is on and pump 2 interrupt is on.
I got the fact that the pump 2 lamp was on. I didn't catch your other part of the transmission.
First part is the ESS bus light is on.
Okay, good. I copy. The essential bus power is on. And Owen, we have a final remark about this. They do not want that MHF furnace opened. It's to remain tightly sealed until post-landing disassembly.
Okay. Any particular reason that?
Well, as you may be aware, it was an off-nominal thermally driven shutdown because of this evidently because of this cooling problem, and they just like it to remain sealed. No further openings of the MHF are scheduled.
Okay, Marshal Ops Space Lab here. We're going a cylinder now, and we're out at about 15 millimeters long. And it's still slightly concave, so everything looks just fine. The problem I had before for the 331 PI was that I didn't, when I glued the plastic of my canes on there, that it's just a little bit off center, so it's, even though it looks centered in the film camera, it's not really quite as centered as it would look. I have a little bit of lateral shift.
Okay, Byron, we copy your transmissions. Do you find it reasonably straightforward to maintain the zone slightly concave?
Yeah, reasonably. I can almost do it by eye here. I just adjust the speeds a little bit. And it's just very slightly, I'd say like an 85-degree contact angle.
That's extremely good news. The FBM people are very heartened by that. You may have hit on a method for growing cylindrical columns and weightlessness by keeping that contact angle a little bit less than the apparently critical value of 90 degrees.
Right, roger. Okay, there's a 30-millimeter column. Shall I try for more?
Byron, this is 331 PI.
Oh, go ahead.
Well, you can balance the lateral shift just applying a non-zero lateral shift on the rear end plate. And the point is that I would like to have cylindrical columns, and if at all possible, that means 90 degrees of contact angle at the disc edge.
Okay, I understand. We'll get there eventually. I just want to know if you'd like me to go longer. I think I'd like to keep it concave until I get to the point we want to be, and then slowly try and make it cylindrical over.
Wonderful. I think this is feasible, and I hope it works.
Okay, well, I'll try for a little more then here.
Space Labs Marshal Ops for Byron. I wonder, do you have a camera set up so that we could have a look into the FPM or not?
Sure, okay, yeah, hold on a sec. It's right here.
We can take care of the routing from here, but of course we can't do your setups. This is a very exciting moment, the fact you're being able to build these cylindrical suspended zones for the first time there.
Okay, I'm not sure which camera it is. It's,
Well, we are getting module interior video right now, so we're pretty sure which camera it is not.
Okay, and Byron, do you have the diopter on that camera?
affirmative, Bill.
Great.
Get it right side up first. I think we just lost our second pump.
Yeah, we copy on the second pump.
And Space Lab, this is Marshal Ops. If you get the camera set up before we go LOS, we can start the recorder for you. If you don't get it set up, that's okay, but we would appreciate getting a little magnetic videotape recording of your growing this suspended liquid zone.
Okay, Mike, that sounds good. Yeah, as you know, we have about 15 tapes still left here, and
at our count,
right, good idea.
At our count, you have at least 14 tapes available for whatever use. So I think you are presently routed from that camera to VITR number 1. There's 48 minutes of tape on it, and it sure seems a shame to bring back unused magnetic tape.
Okay, that's a fair image now, if you can switch. Hey, how's that look, guys?
Okay, Space Lab, we're sending up a command to switch over to that camera so that we can see what you're seeing. Hey, there it is.
Wonderful. Byron, this
Okay, you ready for some more?
I would like to have a 5 RPM of iso-rotation just to check for the axial symmetry.
Okay, well, it's not actually symmetric. Here we go. As you can see, I was not able to get that other plate glued on exactly symmetrically.
Don't worry too much. Byron, then the main point is, without allowing for the breakage, try the iso-rotation step. That is, increase both speeds slowly, but of course without allowing for braking.
I'm sorry, I missed part of what you said, Isidoro. Continue the iso-rotation, you say, and you'd like to grow some more?
Yes, go to iso-rotation.
Okay.
And Space Lab, we're about to go LOS, but your recorder is running, and that was a really terrific show, Byron. We're delighted.
Okay, that's super, Mike. Well, I'll continue to try some more, and I'll put it on tape what I'm doing.
Real good, and there's lots of tape, so keep them rolling.
Okay, we'll go.
and we'll see you at 6+02 at Guam.
Okay, and for the tape recorders, I've got the front plate setting of 23.8 and 20.8 right now, and I'm going to 33.0 and 29.0. Speeds are 0.2 on the front and 0.19 on the reservoir right now.
Real good, Byron. We copy those numbers. Real good.
Okay.
And Space Lab Marshal Ops, we've got you for about 3 minutes through Guam.
Okay, Marshal, you're coming through loud and clear, Bill. Got a quick question for the fluid physics module people.
Go.
Byron 331 PI.
Roger, Zadora, we have a column 48 millimeters in diameter, very nicely cylindrical shape, and I wonder where you want me to go from here. This is the maximum we can get with the current FCM setup.
Did you say 48 millimeters of disc separation?
That's affirmative.
And why did you say that it is the longest attainable separation?
Because we have John Taday's end plate in one side, and Mike Haynes' plastic cylinder on the other side. So we're back at the farthest end. Over.
I understand. Okay. Did you go for the spinning to try to the isorotation instability?
Okay, not yet. I was waiting to get in contact with you and see which way you wanted to proceed.
Can you repeat, please?
Roger, I was waiting to come into voice contact to see how you'd like to proceed. Understand you'd like to speed up iso rotation until we get near the C mode instability or the M4 shape.
Yeah. At this disk separation, you surely will have C mode stability, and this is the way I would like you to proceed. Yes.
Okay, very good. I will do that, and it will be on videotape as well as on your movie camera film.
Copy.
And Space Lab 30 seconds. We'll see you on S-band at around 6:21, and be advised that we may have a little trouble locking up before we get to Mila at 6:30.
Okay, copy, Bill. We'll see you then.
And we also hope to flow some real-time video down from you and have a look at your column at that time.
Oh, I hope I still have it.
Yeah, if you still have it, let's hope.
Payload max dumping.
And Space Lab, this is Marshall Ops through TDRS for about 48 minutes.
It's beautifully clear up there.
And Space Lab Marshall Ops, we've got you for about 47 minutes. How copy?
Okay, Bill, reach you loud and clear. Stand by a couple minutes, okay?
Okay, I just advise you we may have a little bit of a ratty data pass, but hopefully we can copy your transmission, and Isadora is still enabled.
And Marshall Ops, Space Lab?
Go ahead.
Okay, if you can just log down there for the metric camera. We took about 6 pictures here, wherever we are, which is 52 north, 120 west.
Okay, and we copy that, Byron.
Okay. And while I'm standing up here, Bill, we've got some interesting news for the 331 and the FPM people. I was able to get a C-mode oscillation started about 12 RPM with this particular column length of 48 millimeters. And what happened was, as soon as I got the C-mode going, the contact angle at the Perspex disc became greater than 90 degrees, and the fluid started flowing back along the disc onto the feeding end plate. Excuse me, the feeding end plate.
Okay, Byron, we copy, and 300 is listening.
Byron 331 PI.
Stand by, please, 2 minutes. Okay, Marshall, I think we took about 40 pictures or so during that pass.
Okay, we copy 40 pictures. Super.
Yeah. Oh, yeah, it was really clear out there. Just gorgeous.
That's terrific news, Byron. Glad you're getting some clear weather and some reasonable photography in this minus Z nadir attitude. We do have 2 other revs scheduled for Earth observation photography, passes over Europe and I believe North America coming up for the red team to do, so leave them a few pictures too.
You betcha. I guess there should be about 100 left, right?
I believe you have about 100 left right now, which will be great.
Okay. Okay, I'm ready to begin for the fluid physics, people.
Okay, 300's here, and I'll get them in touch with you.
You know?
331, Byron 331 PI.
Yes, Isadora, 321, we read you loud and clear, and did you copy my comments a few minutes ago about the fluid spreading over the feeding end plate during the C-mode rotation, over?
Yes, I copied. Did it went on the whole of the disc, or it just detached on one side?
Oh, no, it started initially, I guess, it's hard to tell where it's attached, but it started to flow over the edge of the Perspex Mike Haynes' syringe disc, and very slowly oozed back out onto the feeding end plate. I noticed this once that I had lost my cylindrical shape, so I stopped the rotation and drove in a little bit on the reservoir to put some more fluid in there. And then as I started to sit up again, I saw what was happening, so I continued as best I could and finally ended up with a broken column. And I'm now about 5 millimeters away from rejoining the 2 columns. So it looks like both ends of the fluid have spread over both plates. So I think we're probably effectively finished with this run, over.
Okay, try and film in the videotape the recover of the drops, the merging that has been so difficult to achieve in other attempts.
Okay, I will do that. Also be advised that we did not have the lighting set up as was in your procedures due to the television camera here. What I have is the meridian zone closed and a green dot, the background illumination only. The camera settings, however, are per your instructions, which is, I believe, a shutter angle of 110 degrees and 8 frames per second at the cine speed and an f-stop of f4. So when you go to analyze your film, you might be aware of that when you process it over.
Copy. I think this is not a great problem.
Okay, I will start the tape record. Drive the both of them together until we get contact.
And Byron, I noticed you're recording.
That's firm, Mike. Okay.
Real good. If you have something exciting to show us, we might be able to arrange some real-time downlink this pass.
Okay, well, the only thing exciting would be the merging, and that's going to be on television, too. Okay, we're 2 millimeters now. Millimeter. I'm about ready to go to cine mode here. Well, that happens in a hurry. Okay, it's on the TV camera, but not on the movie film again. It looks like it almost jumped the gap. Looks like there might have been some electrostatic effect there.
Iron 331 PI.
The one thing, Roger, go ahead, Isidore.
Just to ask you if the liquid is still attached at the edges.
I'm sorry, say again, please.
Is the liquid attached to the edges of the frustum cone plate?
Negative. The liquid, well, it's hard to tell. There is a discontinuity. There's a bunch of liquid that has spilled over onto the actual rear end plate, but it looks like the liquid is now attached. It looks like we have sort of a John Tadei captainoid type shape sitting here.
Roger, I copy.
Okay, and even with the warning, I still didn't get that on cine mode. It happens extremely rapidly.
Sounds like it's a good thing we have the video there.
Roger. The interesting thing is that there doesn't seem to be any type of hysteresis or effects when you form a catenoid type shape and then let it sit there. The liquid doesn't seem to withdraw off of the wetted surfaces around the end plate that we'd like to see.
Iron 331 PI.
Oh, go ahead.
I would like you to start 5 p.m. ISO rotation to check for the edge attachment of the new made end plate.
Okay, I'm sorry. You said 5 RPM and then I missed the rest of it. Uh, 331 PI, please repeat all after 5 RPM, ISO rotation.
The point is for you to verify that there is a sharp liquid edge at the end of the feeding end plate. And for that purpose, I suggest you start a 5 RPM ISO rotation.
Okay, I understand. We have 5 RPM going here.
By the way, I think you could leave the 5 RPM all over because it cannot damage the zone, and it will help a lot to interpret the film afterwards.
Okay, I copy.
Do you think that cylindrical columns are still attainable with the present configuration?
Well, I think we need to make some new end plates. You need to have end plates that have a actually a very sharp shape, so that rather than coming across 90 degrees, that they actually are beveled back to the inside, so that you have a much higher contact angle if the liquid tries to go over the edge. It would also, I guess, be nice to have some sort of a true anti-wetting thing, maybe Teflon with a metal plate built up on it with a bevel cut into the back of it. That might help.
Byron, yes, that sounds like a terrific idea. Just earlier this morning, we went through a potential redesign in which each end plate has a pedestal standing on it with a sharp-edged disc to give a precise contact line at various contact angles.
Roger, I think it's possible to do that, Mike. I mean, I had a nice cylinder up here with 90 degrees of contact angle on the front edge of the disc. The problem is, as soon as we tried the C mode, it went around the edge and saw a 0-degree contact angle and said, "Oh, I'm going this way."
We copy, Byron. Right.
Okay, well, I think that's all I can do here, so I think I'll go ahead and start cleaning up my ton of oil.
Byron?
Go ahead, 321.
I would like you to prepare for 327 Mike Haynes with the existing feeding plate, of course, once it has been cleaned, and its special rear plates to be able to have a TV downlink at 750 oncoming AOS.
Okay, was that the 750 or 715?
750.
Okay, yeah, I think we can get it cleaned up in an hour here.
Roger.
Okay, it seems to help, Isidoro, to get the bubbles out of the fluid to spin it. That was a very good suggestion on your part.
Okay.
Okay, so I'll be quiet here for a few minutes while I start the cleanup. Now, even though this is a 5 centistroke fluid with tracers, I don't see any sign of tracers today. Oh, yes, there they are. You just need the meridian illumination. Okay, they're fine. Would Mike Haynes be amenable to me using this 5 centistroke fluid with tracers for his experiment?
Yes.
Okay, very good. Well, it's a very interesting phenomenon when I stop the plate. We have a definite humping out here during the centrifugal acceleration, or the iso rotation, so I'm going to go ahead and film what happens when we stop, just to show you.
Thanks.
And Space Lab, Capcom needs a loop.
Space Lab Houston on air to ground 1.
Right, Houston, Space Lab here.
Roger, we're trying some Route 21 ops, and you could help us decrease the heat load by turning down some of the lights. We'd appreciate it if you could do that.
Okay.
Okay, that's it, and it's back to martial ops.
Okay.
Byron 331 PI.
Roger, go ahead, Isidoro.
While you are busy with the cleaning, we would like for you to switch off the FPM power in order to leave it just have some breath.
Good idea. Houston, Space Lab.
Space Lab Houston, go ahead.
Roger. We can do, if you'd like, is turn the temperature up in the module a little bit. We're really pretty chilly in here. That may help your heat load also.
Stand by. Okay,
we're sitting on a cabin temp setting of 5 now.
Okay, give us a minute to look at it, and we copy a cabin temp of 5. Space Lab, Houston.
Go ahead, Houston.
Roger. Raising the temp in the module will help us a little bit. We want you guys to stay comfortable, but a few points on that temp set will probably help us a bit.
Well, we've been really chilly in here most of the mission. It's been really pretty warm in the orbiter, though.
Okay, Roger. We copy and thanks.
Roger, we'll go up to 6, see what happens there.
In Space Lab, we may be losing you here for a temporary data drop. In Space Lab, Marshal Ops in the blind, we're in a tail-down attitude, and we won't be able to communicate with you maybe here for the rest of the pass. If you copy, you can acknowledge if you have time. And Space Lab, Marshal Ops, we may have acquired temporary lock, so how copy?
Read you loud and clear there, Marshal Ops.
Okay, got a quickie for Owen. There's a CPAC operation scheduled at 7 plus 35. I think possibly your PCAP shows it. That's 4 minutes. It really is a 15-minute operation. There are 2 models, and you can run it per the PCAP.
Bill, tell me again, which PCAP? You talking about our new revisor, not a teleprinter, or our old PCAP?
Your old one, Owen. Should be in your old one.
I haven't even looked at that.
Okay, let's make sure we have the same data.
Bill, is there any change on the 217s that are shown there?
There are no changes, Owen.
Okay, that sounds fine, no problem.
Okay, and you know you got to do all the dep opping and stuff that we've done before.
Let's just kind of review that. Dep op and make sure that the is probably op 21 again on general principles.
Yeah, let us make sure we got all that whole story straight. It changes hourly. And the Space Lab Marshal Ops for Owen. Okay, this is the sequence. We want you to op route 21. We want you to op the IU dep, and we want the panel dep on.
Sounds fine.
Okay, and same thing. If we get into trouble, back out of it. But it may work okay. Hopefully, the temperature change that you made in the cabin is supposed to lower that RAL temperature.
Okay, we'll see if there's any difference. Or 20 minutes ago, we had a very nice pass right down the Mississippi Valley, the same sort of route we fly back and forth between Huntsville and Houston hundreds of times for the last 5 years.
Oh, great. And we understand on that pass that you were taking some 33 pictures also.
Not quite sure where they were, somewhere along that route.
Yeah, okay, we copy that. And Space Lab, we're going LOS. We'll see you at about 7 plus 55.
Okay, sounds good. We'll be set up for some live TV here for 327.
Okay, we copy that. And Space Lab Marshal Ops through Tidris for about 49 minutes.
Oh, Marshal Operations, Space Lab up here, and we read you loud and clear, Bill.
Oh, thank you, Byron. And we have Mike Haynes standing by.
Okay, very good. Well, I'm all set up. Let me give you a quick jump on Owen's CPAC. He tried to set it up and run it and was totally unsuccessful. Kept getting the rail skips and couldn't get any communication with CPAC.
Okay, we copy.
Okay, and experiment 327, PI. Dr. Michael Haynes, Eddie Reed, over.
Read it very well, Byron. Glad to hear you.
Okay, very good, Mike. Well, we're all set up for your experiment. I have just repowered up the FTM, and I have the plates within about 1/10 of a millimeter of touching, and I'm ready to back it out and start a drop.
Okay, Byron, before you go on that, I'd like to relay a message to you from the Fiat engineers, Mr. Cerato and Mr. Librini. They are both rather concerned about the long periods in which the FPM is being operated in its present mode. I'm sure you understand. As a safeguard, they ask you to make the following check. Would you check with your hand the surface temperature of the electronics box, which is located under the rear left side of the FPM in its extended position? Over.
Okay, it's not even, just barely warmer than the surrounding metal rack.
Okay, I'd ask you to make that check periodically, and also the cover of the lamp housing, which may get rather hotter, which is on the top mid-left-hand side.
And Space Lab, we're ready to flow live TV whenever you give us the word.
Hey, Mike, go ahead.
Great, thank you.
And Mike, I understand the concerns about the equipment, and we'll keep our eyes on it and our hands on it. Everything feels very cool now.
That's right, keep cool, Byron. Okay, can you hold off on the wetting until we get a TV picture, which I think is imminent?
Oh, sure. Oh, no, where did that fluid go? Oh, that's okay. That's all right, no fluid. You worried for a second.
Okay, we copy.
Okay, and experiment 327, PI. Dr. Michael Haynes, Eddie Reed, over.
Read it very well, Byron. Glad to hear you.
Okay, very good, Mike. Well, we're all set up for your experiment. I have just repowered up the FTM, and I have the plates within about 1/10 of a millimeter of touching, and I'm ready to back it out and start a drop.
Okay, Byron, before you go on that, I'd like to relay a message to you from the Fiat engineers, Mr. Cerato and Mr. Librini. They are both rather concerned about the long periods in which the FPM is being operated in its present mode. I'm sure you understand. As a safeguard, they ask you to make the following check. Would you check with your hand the surface temperature of the electronics box, which is located under the rear left side of the FPM in its extended position? Over.
Okay, it's not even, just barely warmer than the surrounding metal rack.
Okay, I'd ask you to make that check periodically, and also the cover of the lamp housing, which may get rather hotter, which is on the top mid-left-hand side.
And Space Lab, we're ready to flow live TV whenever you give us the word.
Hey, Mike, go ahead.
Great, thank you.
And Mike, I understand the concerns about the equipment, and we'll keep our eyes on it and our hands on it. Everything feels very cool now.
That's right, keep cool, Byron. Okay, can you hold off on the wetting until we get a TV picture, which I think is imminent?
Oh, sure. Oh, no, where did that fluid go? Oh, that's okay. That's all right, no fluid. You worried for a second.
Okay, Byron, we see a very nice picture of you.
Okay, I'm just readjusting the TV camera here so you'll be able to see a good picture of your experiment.
Excellent.
And Space Lab, we see you have that camera just about set up there. We're ready to route that camera to downlink whenever you're ready, Byron. Just give us a word and we'll do the switching.
Okay, stand by 1 minute here. I'm just doing the final tuning up. Okay, you can go ahead and switch to that one if you like.
Real good, Byron. We're taking care of that changeover.
Okay, let me go to black stretch and see if that helps.
Okay, there's our image.
Okay, we get a lot of reflection, but I don't think it can be helped.
And Byron, is that a bubble that we see in the middle or what?
No, that's the, hold on a sec. You can see a very slight separation there between the plates. The raised portion is the end of Mike Haynes' 339 capillarity experiment piston, and it's been glued onto the feeding end plate, or actually stuck on with double-sided sticky tape. And that's just a protrusion in the plastic. Once I form the bubble and back it off, you'll see what I mean.
And
there's a slight gap there between the plate and the raised center portion of the plastic.
And Space Lab, be advised, we may have some S-band dropouts, but we should stay with our K-band.
Okay. Mike, I'm standing by. Which set of settings would you like me to use, or do you have a new set?
I'm still interpreting what I see in the picture, Byron. Can you tell me what is on the front plate?
Okay, on the front plate is the part of your syringe that has the hole in it from your 339 experiment. You can see the threads, and you can see the little raised portion in the front.
Okay, I understand now. Well, first I'd ask you to back off with the front plate, if it's to increase the plate separation, if that's possible. Over.
Okay, we're coming back out. Come out about 10 millimeters or so.
Okay, hold it there.
And Space Lab, we're going to put the master in hold to do a little bit of maintenance on it, so don't become alarmed.
Okay, Byron, I see what we've got now. I wonder if it's possible to increase the size of that drop by feeding it slowly. You might need to feed very slowly by making a differential movement of the plate and reservoir.
Okay, now you want to make a drop. There's no drop there yet.
Okay, understood.
Okay. Okay, we're starting to grow. We'll be growing a drop now. We have had rotation there, which I didn't expect to have.
That iso rotation is fine. That helps us to check the actual symmetry of the drop.
Okay, well, I'll go ahead and start it then.
It should be on 5 RPM.
Roger, 5 RPM. I grow it a little faster than that. Hey, just getting some bubbles out here.
Okay, Byron, I can see the drop beginning to form now. Byron, some advice. It might be
slowly going to spread over the...
Okay, yes, it's spread back, but it might...
Okay. Right, okay. There's a little more separation here so we don't accidentally jet onto the plate.
Right.
Yeah, we all vote with you on that one, Byron. We'd all like a little more separation there.
I'm not sure what happened there because I had both speeds set the same, and we've already touched.
Okay, I see some liquid on the rear plate.
Yeah, sorry about that.
Not to worry, we're going to see something interesting when you bring it up to contact, I'm sure.
Oh, well, yes. Okay, stand by a sec. Okay, should we go back some more?
Okay, Byron, I think that's ready for contact now.
Okay, you want a bigger bubble than that? We can get quite a bit more than that.
What I'm worried about is the liquid running back up the thread on the syringe end.
Oh, okay. I think you're okay. I think we can do quite a bit better than what we got right now, but I see what you mean. Okay. The problem is when we spread here, it's going to rupture immediately.
Okay, Byron, it's up to you. If you feel confident to produce a bigger drop, you might like to use the manual adjustment in order to increase the drop volume, rather than doing it with the mechanism.
Oh, that's a good idea. I should have done that in the first place.
Oh, that's beautiful, Byron.
Okay, I think hey, here we go.
Contact.
Yeah, a little late on the cine camera again.
Never mind, we certainly got it on video.
Roger.
Byron, can you hold it there for a while, because it's slowly spreading across the rear plate, and that's what I'm interested in.
Sure. Okay, I see. I made a mistake there, Michael. That didn't stop the translation soon enough. I think we're touching here.
Yeah, I just worked that out. I can see where the threads are. Okay, you've gone rather close.
Okay. Okay, well, that was one. I've got another clean end plate here if you want to go have a go at that one, or if you want to use a wetted one.
I think that with a little time in hand, maybe the best thing is first of all to wipe off this present end plate, and we'll do a spreading run on a pre-wetted plate. If you can just wipe it off with a Kim wipe so that it's merely moist.
Stand by. We'll be getting a plethora of error messages here in a hurry. All 19 alphas.
Stop. That was a beautiful break we got there.
And I think there's a satellite drop suspended middle of that zone.
Yes, there is, Mike.
I can see it.
Moving slowly up towards the...
It's traveling upwards, I believe, and it's about ready to reattach with the...
Right.
We saw that
That's
very clearly.
reattached now, I think. Good. Excellent. Power of video. Okay, I'll try and be a little more careful this next time and see if we can't have a better run here. Problem is we're going to need to move back out some more to clean it. I also think talking to Owen, Mike, about bubbles in the reservoirs, I am convinced, he's convinced also that we've got a very large bubble in there, which I think we can get out.
Yeah, we just saw that.
And Byron, those 19 error messages we're looking at on the ground.
Okay, Bill.
Hey, Byron,
We have a feeling that the bubbles come from the dissolved gases in the fluid.
what we saw there, Byron, was a very clear electrostatic effect. I think the drop was pulled out towards the rear plate.
Ah, okay. Well, it's actually bubbles in there now.
Yeah, we see. Mel says it's burping.
Byron Lichtenberg.
I'll attempt to clean off the plate here. Get rid of that bubble first.
The burbling was Lichtenberg attempting to get the trapped air bubbles.
Peeing off the surface.
Okay, Byron, Mike Haynes, can we look ahead a little into this run? And I like very much your improvised feed plate, but the one which was used previously was not that part of my old syringe, but the disc which was on top of the plunger of the syringe. Do you read?
That has no hole in it, though, Mike.
Yes, there is. It's a small screw hole for a set screw, and it was used by Isidoro in the last run.
No, guys, this is the same setup I had for Isidoro's run.
Affirmative, yeah.
Oh, I'll take a look at yours,
But meantime, the one that you've got is providing some great interest down here on the ground, so please carry on with that for the time being, and if there's time later on, we can go back to the Isidoro stroke Haynes end plate.
This is the same end plate I used for Isidoro. The only thing changed was I used John Tadde's rear end plate. Looking at your piston here, that the piston, which is inside the cylinder, does not have a hole all the way through it. This is the only one that we could put on that has a hole through it to feed the liquid through.
Ah, okay. Now I see where the misunderstanding has come. The piston in the syringe has attached to one end of it, to the end which stays outside of the syringe, a circular disc of perspex of 30 millimeters diameter. Now that does have a hole in it because it's fixed on with a screw to the end of the plunger, and it's cut away in order to fit into the recess in the end plate. You remember the one?
Yeah. Well, actually, no. I mean, I've got it right here in my hand, and yeah, it's fitted into. Wait a minute. Okay, Mike, I understand. I see what you're talking about. But I'm not sure how we'd have fixed that one at a pedestal at all.
No, the intention was to fit it over the feed hole in a standard 40 millimeter disc, centrally over the hole.
Okay, I understand.
Good. We're not sure whether the idea will work, but it might be worth a try later on if you have a moment at the end of this run.
Okay. Okay, sorry about the misunderstanding.
No problem, because we're still seeing very interesting things. But the advantage of the disc, which we've just been speaking about, is that the edge is undercut if you fit it on the right way round. And this might help to anchor the contact line.
Yeah. The only problem I have is trying to get those bubbles out. It's very difficult. Okay, well, So like this for a sec, and we'll wipe off the disc, and I think I can get some more bubbles out when I have it out here. Partial opposite, Bill, are you there?
That's affirmative.
Did you get any story on the problem with CPAC?
It's still a Route 21, Owen.
Whole sequence, and just never managed to make any headway at all.
Okay, we'll let you know.
Anything else on the old plan, like the dosimeters that you want done today? I would assume that you want to wait another day on the dosimeters.
Yeah, I'm sure that's true, Owen. Let me check that, but it wouldn't make sense to take them out now.
So I assume there's nothing on the old flight plan that we need to pay attention to, so from now on that's all of the updates.
Yes, I'm sure that's correct. If it's not, I'll get back to you.
Lichtenberg now cleaning off the disc, the fluid that had come out and spread across the disc
Operation Byron.
during the last attempt.
Right.
Additionally, Lichtenberg's been working to remove trapped gas from inside the syringe used to feed the liquid and form the drop
Byron,
of liquid.
to adjust the focus on the camera a little, we seem to have lost focus.
I was just going to do that.
That's nice and sharp. Oh, she passed it.
Okay,
There you go.
we are again. Trying to do a better job this time. Okay, a bubble.
Okay, we see a nice drop growing on the tip. Now it's spread back.
That was pretty good, Mike.
That's a fine-sized drop. It's beginning to spread back up the
Hey,
thread.
here we go. Yes, I see that. An electrostatic effect.
Yes, we saw that. That was beautiful. No,
Well,
Byron, could I ask you to
just
inject
float it down. It's either electrostatic or it's the inertial effects of moving too fast initially.
No, I'm pretty sure that the drop was deforming before you stopped. Okay, maybe next you could feed some more liquid into the zone and we'll do a zone break.
Okay. That works.
That's a beauty, Byron.
Okay, here we go.
Byron, before you go, might be interesting to do some oscillations on that zone just to see if it has any standing waves. If you could do a slow ramp with, say, a 0.2 amplitude.
Okay, what frequency would you like to go to?
I'd like you to do a slow ramp and just keep going, and we'll see what we see.
Okay. Okay, here's 0.2 millimeters, okay?
Okay.
Okay, I think we're already up at 2 hertz now.
Yeah, it looks like 2 or 3 hertz on the screen. Okay, Byron, can you go to a higher frequency than that?
A little bit. I think that's about it, about 2.4 hertz, Mike.
That's your limit, is it? Okay, that's fine.
Okay.
Okay, I think we've got all we want out of
Shall I
that.
stop?
Yeah, please stop and I think the next thing then is to go back to a zone brake.
Okay. I'll come out a little slower this time.
That's a beautiful slow stretch you've got there, Byron. Please, will you stand by to stop when I give you the word? Stop, Byron.
Okay, we stopped.
Absolutely perfect. And again, we saw the satellite drop, this time moving downwards.
Oh, you have better eyes than I do. I can't see it in there at all now. And I was able to film that one on the Vinton camera also, Mike.
Ah, that's perfect. We'll get some good slow motion of that one.
Okay, want to reform?
Yeah, I think maybe do a fresh drop, but without cleaning off the rear plate, and we can look at the union of the two drops this time.
And Space
So you
Lab.
want to go a new drop here?
Space Lab, this is Marshal Operations for Byron.
Go ahead, Michael.
Right. According to our payload activity planners, your duties for the day are over starting 1 minute from now. And it's your choice what you'd like to do for the rest of the day. If you need to take a break, you can certainly do that. If you want to take the day off sightseeing, you're also invited to do that. And if you'd like to do some FBM experiments, you're also invited to do that. We're willing to support you any which way.
Okay, well, we'll stay here for a while. This is a lot of fun.
We're having fun too, Byron, and while you're at it, will you check that the electric potential is switched at 0, because we can see a clear electrostatic effect on the screen down here.
Oh, Roger, it is 0.
That's remarkable, because it appears to us, maybe you can check visually up there, that the drop on the rear plate has a protuberance right in the center.
It sure looks like it, doesn't it? Yeah. Yep, I confirm that visually.
Okay, now, maybe before you do anything else, can you approach the rear plate with the drop that you have on the syringe?
I will. Slowly.
Great.
Okay, here we come at lowest speed.
While that's going, Byron, I wonder if you can put the Vinton onto one frame or so, just so that you get a high-resolution picture of this.
Sorry, say again?
Would you try and get this on the Vinton as
Okay.
well?
That's all right. That's what I'm trying to do. You just try it.
Okay,
We got it.
Yeah, we saw something absolutely remarkable there. Thank you very much.
Good, because I was... Okay, well, I was busy flipping the switches, so I didn't see it quite as well as you did.
Let me tell you what we saw down here. The drop on the rear plate grew a more pronounced dimple as the drop on the syringe got closer to it, and then it spat once or twice across the gap, as we saw on STS-9, and then it finally, the two drops were attracted to one another and joined very abruptly. Check if you've got translation still on, it might still be moving.
Oh, the translation's been stopped.
Okay.
Okay, where would you like to go from here?
Okay, Byron, now we're looking ahead. We've only got a couple of minutes of TV time left. During the period when we can't see you, that might be the best chance to change over the discs if you can improvise some way of fitting that disc, the larger 30mm disc, onto the front plate. Over?
I understand you want to larger disc, okay?
Yeah, the Perspex disc, 30mm in diameter with the undercut edge, and it should be fitted on with the larger diameter part facing the rear plate.
I understand. Okay, well, we'll draw the liquid here then. I'm just doing it manually.
Yeah, we're watching it.
A break induced by reduced reduction in volume.
Let me just confirm one thing with you, Byron. The attachment of that disc to the front plate, the smaller diameter part should be on the feed plate, the larger diameter side of it to the rear plate, so that it appears undercut when it's viewed in profile. You understand, over?
Yes, I understand that.
That's fine. And we really are getting some marvelous pictures down here. That's great stuff.
Oh, that's good. I think it's going to go here.
Right.
Look.
Okay, Byron, if you succeed in attaching that disc, then maybe you can store on tape for me one spreading experiment of the kind that we've just seen on this smaller end plate, but using the 30mm disc, okay?
Okay, I'm sorry. Could you repeat, please, Mike?
Okay, I'd ask you, if you succeed in attaching the 30mm special end plate in the way we described, would you then record on tape for me and store one wetting and spreading experiment of the kind we've just been doing?
Okay, understand you what? Where do you want me to record it? On the,
Yeah, we'll still be listening to you, but we shan't see it, but maybe you could just keep it for us on tape for when you come back. We'd appreciate it. Thank you.
If you could speak just a little slower, the quality of the comm is going downhill slightly, Mike.
Okay, let me repeat once more. The special 30mm improvised end plate, if you succeed in attaching it, then maybe the first thing you should try is to grow a drop on it and contact it with the spreading disc which you have in the FPM at the moment, and keep a VTR recording of it. We'll be listening to you, but we shall not be seeing you.
Okay, I understand.
Great.
And Space Lab, this is Marshal Ops for Byron.
Roger, go ahead, Mike.
Yeah. Depending on how eager you are to give it a try, there's been a suggested experimental run coming up about 11 and a half hours that the 102 team would like you to try if you're willing to give it a go. It should take about 20 to 30 minutes.
Okay, well, tell me more.
Okay, I've in fact agreed not to tell more because it's supposedly a kind of a surprise FO, and the details, in fact, are not even been completely explained to me. But Larry and Chuck have cooked up a little test that they'd like you to try if you feel you're willing to give it a go.
Okay, yeah, sure.
Fine, I'll give them a go-ahead.
I'll be shutting down the fluid physics module here for a few minutes while I clean up. And for Mike Haynes, do you want to leave the already wetted disc in the back here?
Negative. I think if you have a spare virgin disc, then this is the time to try it.
Okay, yeah, I have one more disc here that's dry.
Okay, that's fine. And just to confirm, the disc on the end of the plunger, the model that you have in flight, I believe is attached with a brass set screw. Is that correct?
Sure, that's the one we'll be using.
Okay, that's a relief. That goes centrally over the feeding hole, of course, in the 40mm plate.
You understand?
And, Byron, just a brief message from our sponsors. Fiat, again, would be very happy if you would check from time to time the temperatures.
Roger, I just reported I'd shut the FPM down. It's powered off for now.
That's great. Thank you. Understood.
This is Mission Control Houston. The change your shift briefing with STS-9 Lead Flight Director Chuck Lewis
As you said, undercut.
begins momentarily in Building 2, Room 135 at NASA's Johnson Space Center,
Warm
Houston.
at this time, and just a little mild concern for the one you've been looking at through the FPM. And Space Lab Byron, we'd like to have you turn that TV camera off you're looking at into the fluid physics module with. If you got... Reason for that is, Byron, it's getting a little bit warm and bumping up against the high end, and we'd like to make sure we don't hurt the camera.
Roger, I'll turn it off here, Bill, until we're ready to go again.
Okay, when you get ready to run again, you can turn it on.
This is Mission Control Houston. The change your shift briefing with Lead Flight Director Chuck Lewis begins presently in NASA's Johnson Space Center newsroom, Building 2, Room 135.
Give you the other camera 2, the end shot, if that's okay.
That's affirmative.
Turn the wrong one off? Please just turn them back on.
Yeah, you turned the wrong one off, but we got it right.
I have to disagree with you because they're both on now.
Okay, we're working at it.
Okay, how about that?
And Space Lab for Marshall Ops for Owen, if you have a chance, we've got some copy here before we go over the hill in 8 minutes.
Stand by, Sexville.
Space Lab for Byron, we'd like you to make another temperature check and also check that the camera is off, if you would, please.
Roger, I did. They both, the camera's off and the FPM is off. Bill, go ahead, ready to copy.
Yeah, we have a CPAC run coming up here at 9 plus 40. It's N2 FO13A. And the TLC that we want you to use is Sierra 02 Kilo 03. It's a model.
That's the same timeline I counted. I believe that's the same timeline I counted before, which is a double Model 17 and has a T0, which is already behind it.
Okay, and the T0 that we have has a day 341 01:50:00.
You were, I missed the time after day 341. What was the GMT that you gave me?
Okay, 01:50:00. And the PCF number 69, we want it to equal 1. And on the op, on the ROW, Owen, we'd like to have you do a ROW 21 op. We want the depth to equal op. And the panel IU depth switch we want on. In that sequence.
Okay.
And if that does run, the shutdown will be at approximately 10:17.
There's a problem that I see in my in the old PCAP, the original PCAP. It's that same timeline, Sierra 02 Kilo 03, that was intended to be called in at about 07:33, and it was expected to have a T0 of 23 hours 37 minutes, not the one you just gave me. Have you modified that timeline already from the ground?
No, I guess Mom's given me some the correct data here. Stand by.
For me to run it manually with the information you've given me, all I need is an exception monitor timeline, which I probably already know, so I can run it manually as easily as not, but it's whatever you prefer.
Oh, and run it manually. We know that data's correct.
Sierra 02 EZ something.
Yeah.
Item rather, India 00.
Yeah. You know, I'm sure that you know how to run it.
There's some question on the exception monitor timeline because we were usually running Echo XX, and now we've been getting some India XX, and so you might want to check on that one.
Okay, Owen, the S02 India 00 inhibits all the exception monitoring. If you run the Echo 02, Echo 00, that enables it. We recommend you inhibiting it.
Okay, so I'll run the inhibit timelines, and I'll run a double 17 starting at 9:40.
That's affirmative.
Change to make you think Route 21's going to behave any better.
The temperature's dropping on it, Owen. We can only hope that it'll be within range when we get to the right time.
Okay, if I give it a Route 21 enable and all I get to see are a series of 3 messages, is there any point in continuing, or should I just hold off until I can get a Route 21 opt without messages?
Yeah, if you get the error messages, you might as well back out on.
Okay.
And we're coming LOS here in about 20 seconds, and we'll see you at about 9 plus 30.
Business.
This is Marshall Space Lab operations, 8 days, 8 hours, 47 minutes mission elapsed time. Loss of signal through the tracking and data relay satellite. Anticipating reacquisition of signal again through TDRS in about 41 minutes for S-band voice communications. About 53 minutes from now, we should reacquire the capability to downlink high-rate data. Space Lab and the orbiter, presently on their approaching the end of their 135th orbit of the Earth. And the orbiter has been in the midst of a relatively long loss of signal period also through UHF ground tracking stations. About an hour and 3 minutes remaining before reacquisition of signal. This loss of signal period, however, in total was about an hour and 40 minutes in length. During the last acquisition between payload control and Space Lab, we received live downlink television from the habitable module of Byron Lichtenberg working with the fluid physics module, and we also received views of the inside of that module as Dr. Mike Haynes here in the Payload Operations Control Center worked with Lichtenberg in one of the fluid physics experiments. That experiment using the fluid physics module, however, also some makeshift equipment that had been put together by Lichtenberg on orbit to help improve those experiment operations. Additionally, Owen Garriott again attempted to operate the space experiments with Particle Accelerator's passive diagnostics package, however, was unable to do so because of continuing difficulties with Remote Acquisition Unit 21. Indications from the Payload Control Center provided to Garriott by CICO Bill Bach are that that ROW is still a little warm, a little too warm, and that's what's causing the difficulty in communicating through that ROW with the CPAC instruments. About 39 minutes, just under 39 minutes remaining till reacquisition of signal at 8 days, 8 hours, 50 minutes. Mission elapsed time. This is Marshall Space Lab operations. This is Marshall Space Lab operations. 8 days, 9 hours, 28 minutes mission elapsed time. Standing by now for reacquisition of signal with Space Lab through the tracking and data relay satellite. Acquisition to occur in just about a half a minute. And following in about 13 minutes, we should be in the position to receive high-rate data from the lab through KU band. On board the laboratory officially, Byron Lichtenberg's operations of the fluid physics activities were over. However, he had indicated his willingness to stick around and continue to work on some fluid physics experiments. We anticipate that's what he'll be doing when we reacquire signal. And we have a new crew interface coordinator on board making the AOS call at this pass, CIC Deborah Underwood, standing by now for reacquisition.
Space Lab, this is Marshall Ops. We have you through TDRS for about 54 minutes.
Hi, Debbie. Good evening. It's good to hear your voice.
Ah, thank you. It's good to hear yours. We have the CPAC PI enabled over the loop whenever y'all are ready to talk to him.
Okay, go ahead. I'm ready here. And how are you this afternoon, Debbie?
Oh, fine, Owen. How are you?
Oh. But you've been keeping the cadre organized as usual.
As usual, yes. I've tried very hard.
There, Mr. CPAC.
Owen, this is CPAC.
About your CPAC.
Roger. Owen, we've been trying to run these CPAC operations and continue to get the REU problems. I assume you're still getting them on orbit.
Yes, I hear this is Bill Roberts, CPAC, this afternoon, and I was actually delaying the RAL op until we got back in contact, so you can see the same messages if they begin to arrive again.
Roger, we have the page up, Owen, and are going to be looking. I think our operation is scheduled to start at 0250 GMT.
That's correct. I haven't put it in yet. I'm going to enter them manually to do the first 17 at 0150 and the second 17 at 0207.
Roger. We're trying to get the ESA-20 gun firing during that period of time so that we can measure the effects of the firings on with the diagnostic package. Owen, we're going to follow...
Hey, well,
Go, Space Lab.
Go ahead, Bill.
Roger. We were going to follow that, Owen, by 4 firings of the MPD arc jet in conjunction with ESA-20 to look at the neutralization effect of the plasma while the ESA gun is firing.
But apparently you plan to do that on another pass because I was about to load in 2 Model 17s at Course Diagnostics.
Roger, we're going to go ahead with the 13, that's Model 17, at 341.0150, followed by the second run at, as you said, 0207.
Bill, I'm not sure that's what we had planned. When we last left, the plan was for me to load in 2 Model 17s manually, and there would, of course, not be any MPD firing, because the only other timeline that was given to me was a Kilo 03, which was already for a time in the past. Over.
Oh, okay, Owen. Fine. Yes, that's correct. We want to run first the 2 Model 17s back to back.
Yeah, I'll do that.
Space Lab for Owen, this is CPAC again.
Go ahead, Bill.
Yeah, Owen, probably let's just run one run of the FO-13A.
Number, is that the 17?
Roger, I'm sorry. Model 17, Roger.
Yeah, I'll start 117 at 0150.
Roger.
CPAC, it looks like perhaps the op of Route 21 is going to hold that time, and I see that your depth is already opt, so we'll go ahead to the procedure.
Roger. Owen, I want to give you I mentioned earlier that we are going to try to run the MPD arc jet in conjunction with the ESA-20 gun on the next pass. Would you like for me to read you these times now?
No, you can wait till after we get started here. That'll be fine. I'll get this one started, then you call them. Give them to me.
Okay, just give me a call.
Bill Roberts here in the Payload Operations Control Center, a member of the CPAC investigator team, working with...
Space Lab PS2 here for the 327 TI.
Okay, stand by. They're enabled.
Byron, Mike Haynes, glad to hear you again.
Mike, well, I've got the thing cleaned up. I've got your new disc on, and I've got a dry disc on the back end, and I'm ready to go.
If you could just talk me through what happens, I'd be very grateful in any mumble mode you can manage. Thank you very much.
Okay.
And Byron, Mike Haynes again. Could I just ask you to make that temperature check periodically once more?
Roger, the fluid physics module's been cooled down now for about 45 minutes. I just turned it on just about 5 minutes ago, and everything is nice and cool as a cucumber.
Very grateful, thank you.
Okay, that's an awfully big plate that we have in there, Mike.
Would you read again?
The feeding end plate is more like 60 or 70 millimeters in diameter, not 40. I think it's 40 radius.
Let me just verify that you have on the feeding end plate that small perspex disc with the undercut edge. Is that correct? Over.
Affirmative, yes, I do, and it is truly undercut.
And do you have any liquid on the plate yet?
Not yet.
Okay.
The smallest, but there's no liquid on the feeding plate. When I brought the two plates close together, we had the same problem of a small drop of liquid, I mean very small, jumping over to the large spreading disc, unfortunately.
Okay, we don't worry too much about that.
Okay. Okay, our tape recorder's running, Mike, and we're ready to go here.
Okay, that's fine. Maybe you'll give me some commentary on the spreading of the liquid across that improvised end plate as you grow the drop. Over.
Okay. Okay, here comes the bubble out, and it's coming across. And there's some air. Forming almost a cone shape with a very pointed edge with that air, I think. Okay, it's coming out some more now. Still a little bit pointed. Now it's rounding out nicely. 1 centimeter. I better stop it. We've got a pretty good bubble here.
That 1 centimeter, is that the diameter or the height of the drop?
That's the height from the plate to the top of the bubble.
Okay, maybe you can very cautiously continue to grow the drop. Are you doing this manually or with the FPM feed? Over.
I'm using the FPM to fill it out there.
Okay, Byron, I think you might get better control if you use the manual drive.
I think you're right. Okay, you're not too concerned about volume, huh?
No, I think we can measure the volume off the image.
Okay. Okay, well, I'll go ahead and put some more fluid in. I think you're right about the manual control. Would you like a very big drop here?
Yes, if you, first of all...
1.5 centimeters high now.
Okay, can you estimate the contact angle of the drop? Has it reached the edge of the disc yet? Over.
I'd say 45 degrees.
I read 45 degrees at the edge of the disc. I think you can increase that towards 90.
Okay. Stand by. I have to back the plates out some more. And for Mike Haynes, it looks like the bubble's holding nicely here. Oh, wait a minute. No. It leaked over the edge. Okay, it went around the undercut edge, and it's now back on the flat metal end plate over.
Okay, I'll read you that it's overspread the edge of the disc. Could you give us an estimate of what the angle at the edge of the disc was when this happened, over?
I haven't changed anything. I thought it was about 45 degrees.
Okay, and you still have a drop of about 1 centimeter height? If so, then you should start advancing it and try to achieve spreading on the end plate. Over.
Okay, good, here we go. CPAC, it looks like maybe it's going to run this time. We've got the dep ready, yes, and the PCF parameter that you wanted is already 69 equals 1.
Roger, thank you, Owen.
Transmission is scratchy. It's pretty scratchy in my earpiece, over.
I was acknowledging.
Roger, I understand. I just wondered if my transmission was satisfactory.
Yes, it was. I could hear you plainly.
The battery voltage at 43.2 is just barely above the minimum. I'm not sure whether the software will check when it gets to anything below 43.0 or not.
No problem with the battery, Owen.
Okay. There it goes again, Mike. You're absolutely right. There's There's definitely electrostatic effect here. It jumped across the gap about 7 or 8 millimeters to form the floating zone, over.
I read a jump of 7 or 8 millimeters. That's spectacular.
Yes, it really is, and I missed it on City, but it's on video. CPAC or Marshall Ops, can one of you tell me whether or not you want to put O2 analog onto VTR number 2 or
On 2.
straight to the ground? Thank you. You want a commander, or you'd like for me to, Bill?
You start the
Do it
recorder.
up here. Okay, Mike, we're now going to the zone by spreading here by constant volume separation.
Byron, I didn't quite read that. Would you say again? Byron, Mike Haynes, would you repeat your last transmission? It was a little garbled.
Okay, we're still separating the plates now, Mike.
Okay, Byron, I didn't quite catch the last transmission before that one. Could you repeat, please?
I said that I injected some more fluid in to make a little fatter zone.
Okay, Byron, that's excellent.
And it's interesting because the fluid on the unwetted plate, Mike, does not spread to the far outer diameter. It looks like it stays about the same diameter on the as the top feeding plate, over.
That's very interesting. I think that will be of interest to John Paday as well.
I think so, too.
Space Lab Marshal Ops for Owen. Owen, just want to remind you that PICTAB will be on between 9 hours 50 minutes and 15 seconds till 9 hours 55 minutes and 15 seconds.
Thank you. And the Space Lab here for 327 Mike Haynes. Now that I think about it, maybe what happened during the drop is not that the liquid flowed around the edge, but that it seeped underneath between the tape and the plastic plate. There are some little holes there. I wasn't able to get it completely covered up. And it's very possible the fluid just leaked out from underneath, so I think we may not have to worry too much about the fluid.
Okay, that sounds very reasonable that it would creep through that capillary space between the tape and the front plate. That's cheerful news, because if it means that you can grow a 90-degree drop, then it gives us a clear go for perhaps another attempt at Isidoro's long cylinder.
Roger. You got the DGP running, CPAC.
Very good, Owen. We're tickled to death.
Bill Roberts in the Payload Operations Control Center reporting that CPAC diagnostics package is up and running.
Great.
Space Lab, this is CPAC for Owen.
Bill?
Owen, do you want to copy the times for the T0 times and the exception monitoring for the MPD arc jet firings, the 4 on the next path?
Right now it's fine. Go ahead.
Okay, the T0 times will be day 341, 02, 22. The next one will be 02, 52. The next one will be 03, 22. And the final one will be 03, 37. The exception monitoring...
I have those.
Roger. The exception monitoring will be Sierra 02, Echo 05.
And Echo 05 applies to all 4 of the preceding operations?
That's correct.
What model number?
It'll be Model 9, Owen. Model 9.
For each one of them?
Roger.
And Space Lab.
Break. Yes, Space Lab here for 327 Mike Haynes. We had a nice break. I recorded it on spinning film, and I've advanced to contact again to join and remove the fluid.
I read that, Byron. Thank you very much. Now, we'd like to maybe go on to see whether you are able to achieve a hemispherical drop, that is a 90-degree angle drop on that end plate. If you can do that, then perhaps you could advance to spreading and do one more spreading experiment for me, and then that will raise Isidoro's hopes greatly, because he would be able to make his long cylinder if after that you were able to remove my spreading plate and replace it with John Padday's 30mm rear plate. Over?
Yeah, I understand. We'll try to do that. I think what I'll have to do is take it off and redo it with the tape, because I need to make sure there's no channel there. Otherwise, I think if the fluid leaks out, it will cause the other fluid to jump around the corner, won't it?
Yes, thinking about it, that is a possibility, because it'll have a negative curvature around the back of that undercut.
Hey, let me finish this and we'll think about it a little bit.
Okay, we're thinking down here as well. Space Lab for Byron.
Roger, go ahead.
We've been considering possible solutions to this interesting problem of the capillary creep of the liquid under the plate, and whether or not you can implement this solution depends on the width of the tape that you're using. Can you tell me what width your tape is?
The width of the tape?
Correct.
Well, let's see. I don't know, half a millimeter maybe?
No, not the thickness, but the width of the tape. Is it half-inch tape or 1-inch tape that you're using?
Marshal Ops, do you think we'll need additional Route 21 ops, or will the first one, the one that we've got now, hold it in for the succeeding model numbers?
It's holding in right now, Owen. We'll let you know.
I'll not plan to reissue that op unless you call me.
That's affirmative.
Okay, Mike, I'm going to try and open the chamber here and redo that end plate before we go any farther.
Okay, Byron, that sounds a good idea. Can I repeat the question? What width of sticky tape do you have?
Roger, it's 1/2 inch, roughly.
I read half an inch.
Yeah, that's firm. Maybe, let's see, about 1/2 inch.
Okay, in that case, the solution we had in mind wouldn't work. An alternative would be to try to form a square of tape surrounding the central hole.
Well, that's an idea. Let me try and put a piece of tape right over the hole and then make a cutout in it.
Yeah, that would be fine. And don't forget the value of peanut butter as an anti-spread barrier and adhesive.
Sorry, say again?
I say don't forget the value of peanut butter as an anti-spread and adhesive.
CPAC for Owen, we find the end of the FO.
Say again?
We have lock off on data.
We've dropped out on the data, is that correct?
We lost HRM.
Sorry, Bill, I still couldn't understand you. There should be about 4 more minutes on the FO.
That's correct, Owen, but we've lost HRM, no problem.
We still got it on the tape recorder, of course.
Roger.
Commercial Ops, Space Lab here.
Go ahead, Byron.
That's a question for the Inco data people, Bill. We had about 16 minutes left on VTR1. I think I've used up most of that, and I think it's about empty. Owen's going to check it right now. You guys want us to change tape?
Stand by. Yeah, that's affirmative, Byron. Go ahead and change it out. And just give us a number after you do it.
will be 18. He hasn't got it stuck on there yet. 1.3 minutes. That's pretty good usage. Oh, excuse me. He's zero. It's down to zero. Missed a little bit of the last part of the run. Hit the end of the tape.
Space Labs to Byron, Mike Haynes.
Yes.
Byron, could we ask you whether you have the FPM powered up at the moment? It might be an idea to switch it off at any time when you're working outside it like this.
Roger, I already did that, Mike. It's all turned off.
Fine, thank you, Byron.
Yeah, sequence start.
Oh, we confirm.
Owen, we have another message on experiment 20. It will be operating every 15 minutes until 11 hours, 35 minutes.
Okay, every 15 minutes for pick pad.
Affirmative.
And Space Lab for Owen?
Bill?
Yeah, Owen, on these Route 21 messages, about the most straightforward advice we can give you. If you get 3 ROW skip messages in a row, you can be assured that CPAC is not operating.
I understand that, and I was just wondering if, as long as I haven't got any messages, if I'd need to re-op it, and I presume the answer to that is no.
That's affirmative.
Oh, and we got a good run. This is CPAC.
Okay, Marshal Operations Space Lab here for the 327 Fluid Physics Module PI.
327, go.
Hey, Mike, what I thought I would do is I've got the Fluid Physics Module out. I don't even need to power it up. You just like to check and see if we can make a bubble with a 90-degree contact angle, right?
Affirmative.
Okay, I'll go ahead and do that with manual injection right here. I can turn the power off for a while.
Okay, that's fine. If you get a 90-degree drop, then maybe you could resume with the lighting so that we can get some videotape record of it and do a spreading experiment, and then we'll hand you over because we have an interesting list of further things to do, and I'd like to, maybe while you're doing this, give you some idea of what we have in mind. Over.
Okay, well, you better let me do one thing at a time unless we're coming up on a short LOS.
Understood.
Do you want any PCF changes with the mountain line?
Stand by one. Oh, and yes, that's the first one. We'd like to have PCF 61 set to 5. PCF 61 set to 5. Also, PCF 71 set to 0.
I think I may have not copied you correctly there, but what I copied was a 5-1 set to 5, a 6-1 set to 5, and a 7-1 set to 0. Is that correct?
Negative on the 5-1 set to 5. Repeat, 6-1.
Hey, you want 6?
Repeat, 6-1 set to 5, 7-1 set to 0.
Oh.
Oh, and we want
Prep is initiated, and your prep is initiated, Bill, and I left the MTV on the switch panel to inhibit. Over.
Rogers, MTV inhibit, correct.
Now, Marshal Ops Space Lab, that reel I just took off is reel number 18, and I labeled it AV1, and it's got fluid physics module date on it.
Byron, we copy reel number 18, and could you repeat the rest, please?
Roger, it's come off of AV number 1, and I also labeled it with fluid physics module, FPM.
We copy, thank you.
CPAC for Owen.
Bill?
Owen, this PCF 61 is a control for the iris. We're now trying to get a calibration on it so that for the other three runs of this Model 9, would you set it to, in each case, 4, 3, and 2? In each case, 71 to 0.
And Space Lab Marshal Ops, we'd like to have you turn off both TV cameras. They're running a little bit hot. And if you have something good you want to capture, you can just turn them back on. But when you're done, just turn them off.
Okay, experiment ops are on. We have both tape recorders running.
Roger, we copy.
CPAC for Owen.
Bill?
Owen, we are running. We are confirming that we're getting data. I want to give you an update on this PCF-61. Apparently, you should set it to 1 for all subsequent operations. Repeat, PCF-61 to 1.
Hey, I'll do that.
Thank you, Owen.
And break, Marshal Ops, Space Lab here for the 327 FCMPI.
327.
Okay, we have a very nice sphere now. Contact angle, I'd say, is about 75, 80 degrees.
I'm at 75, 80. Will you be bold and go for 90?
It looks like we now have about a 90-degree contact angle, Mike.
Okay, Byron, that's excellent news. What I'd like to ask you to do then is to run through a normal spreading and rupture sequence with that drop, and then after that, forget me, Isidoro would like to look at a long cylinder, that's if you have the time to do it, using John Paday's 30mm rear plate. Over?
Okay, I understand. Welcome.
Great.
And Byron, we have something we want you to do on the UHV threshold.
Say again, Bill?
Yeah, we have something we want you to do on the UHV.
Okay, I'm ready to copy.
Okay, we need an op, enter. 1.
Say again, I could not read it.
We want you to do an OPE. 102 442, enter. Want you to verify that line 8 is 072 027. Then CLS 112 700. Enter. Then an OPE 102 444, enter. And I think we're LOS. We want you to then do a close CLS 000, 6 zeros and an enter. If the UHV ops is off, then do a start UHV enter. Wait for the UHV stop or the UHV off, and repeat with a close 4 balls 0 10 enter.
This is Marshall, Space Lab Operations at 8 days, 10 hours, 27 minutes mission elapsed time. Loss of signal through the tracking and data relay satellite system with Space Lab. Reacquisition scheduled anticipated in about 41.5 minutes through TDRS, and we should almost immediately be in a position to receive high-rate data through the KU band portion of the tracking and data relay satellite. During this last acquisition of signal, CIC Deborah Underwood was in place here in the Payload Operations Control Center. Deborah Underwood is a backup crew interface coordinator for Space Lab 1, and this was her first opportunity to sit in the CIC's chair. She is one of the prime commentator crew interface coordinators for the upcoming Space Lab 3 mission. Also, Bill Roberts, a member of the CPAC investigation team, was enabled and worked with Owen Garriott throughout much of the past to set up for another attempt at joint operations with the Experiment 20, PICPAP, the European Space Agency, space plasma physics package. For this operation, the space plasma physics Experiment 20 was to fire its electron beam, and CPAC would be using its diagnostic package, but also was scheduled to operate its magnetoplasma diagnostic arc jet, the release of argon gas. The reports that we received from the crew and from data here on the ground was that they managed to command the unit on through the remote acquisition unit, which had presented some problems earlier in the mission, and indications were that they were preparing for an operation. Also, Byron Lichtenberg worked with Dr. Mike Haynes here in the Payload Control Center to complete the experiment he had started earlier and set up for another of the fluid physics module experiments. At 8 days, 10 hours, 29 minutes mission elapsed time, this is Marshall Space Lab Operations.
This is Mission Control Houston. There were 2 AOS periods during that pass for Columbia, which concluded a rather long period of not having had contact through UHF. We were out of touch between passes for well over an hour. Of course, we retained the capability to use air-to-ground 1 in urgent circumstances, and obviously that never occurred. And in fact, the 2 signal periods through Botswana and Indian Ocean Station were relatively free from significant discussion. That crew activity plan shows an exercise period scheduled for Columbia pilot Brewster Shaw, and Capcom Anna Fisher asked him about that, and he said that he deferred from that exercise period presently because there's other crew members sleeping in the mid-deck, and he'll just take that exercise period later on, although he did verify he has been exercising for a period of 30 minutes a day each day during the course of this mission. We'll reacquire again through Hawaii in about 30 minutes to mission elapsed time, 8 days, 10 hours, 31 minutes. This is Mission Control Houston.
This is Marshall Space Lab Operations, 8 days, 10 hours, 58 minutes mission elapsed time. Just over 30 seconds now from reacquisition of signal with Space Lab through the Hawaii ground tracking station. Orbiter and Space Lab on the descending node of actually approaching the equator on the 137th orbit, passing Hawaii. In this orbit, the orbiter Space Lab will not pass over the United States, but will stay out over the north and then pass into the South Pacific Ocean, crossing the tip of South America. Standing by now for reacquisition of signal.
And Space Lab Marshall Ops to Hawaii, we have you for 4+47.
Okay, we had a good CPAC run, just shutting it down so we can get it started for the next one.
That's super, Owen. And how much of that last UHV transmission did you copy?
Just about half of it. Give me just a moment now while I get to the rest. I got down as far as close 112, 7 double aught, enter, and then the next one was interrupted, so I've got that far and I have to get up with it. Just a moment, please.
Okay, and we do have live video from the cameras in the orbiter bay, and we're looking at the Earth, Owen. It's just a beautiful picture.
We'd have to agree with that.
I wish we could get Brewster to beam us up.
Certainly be nice, and I suppose there's a lot of people in this like to do that too.
Yeah,
That's a roger that.
Why don't you start with that open 102 something else?
Okay, here's Vubo. I'll let him voice the rest of this up.
Okay, Space Lab, this is Marshal Ops for Owen. You have step 1, and then step 2 starts with an open 102444, enter, and a close 6 zeros, 6 balls, enter. Over.
Yeah, I have that. Why don't you wait, and then we'll see if the UHF ops is off at that point.
Roger, you copied, over.
UHV either way. Yeah, Marshal Ops, Space Lab, just to ease your mind here, both TV cameras are off and the FPM is powered down.
We copy.
And when Owen gets finished, I'm in the middle of doing the setup for Isidora's run, and I'll give you the guys a debrief in a little bit.
Great, we understand.
Vubo, do you fellas know that the power switch is off on the UHV?
We copied, power switch off, stand by.
Continuing to receive live downlink television.
Like the whole sequence of them.
Orbiter now passing just east of the Hawaiian Islands.
Marshal Ops, I think you're commanding 19 Alpha, and it's giving us a whole sequence of alarms here.
Yeah, we copy. Disregard those, Owen.
And
Space Lab. Disregard them. We can't disregard the alarm.
We understand. We're going to try to get him to correct it.
Hey, Vubo.
And Space Lab, Marshal Ops for Owen. That power switch of the UHV has to be switched on, and you can just perform that procedure. Just continue with the procedure. Over.
Yeah, I've completed the entry of those commands, and you want me to turn the switch on now, is that correct?
Yeah, that's affirmative.
And we're going LOS, guys. We'll see you in 4 minutes through S-band.
This is Marshall, Space Lab Operations, 8 days, 11 hours, 5 minutes mission elapsed time, loss of signal with Space Lab through the Hawaii ground tracking station. Anticipating reacquisition in about 3.5 minutes, just over 3.5 minutes, through the tracking and data relay satellite. We should receive both S-band voice communications and the capability to transmit from the orbiter high-rate data. During that pass, we received some downlink television from the orbiter forward bulkhead camera. Considerable amount of cloud cover over the Pacific Ocean as the orbiter passed just east of the Hawaiian Islands. Here in the Payload Operations Control Center, shift handover just now beginning to get underway as the red shift begins to arrive, and in place, alternate payload specialist Hubo Ackles. During that pass, he provided some guidance to the crew on one of the material science investigations associated with the double rack, but actually using some separate equipment that is not mounted into the double rack. Byron Lichtenberg in the process of cleaning up fluid physics module activities that he'd been conducting over the past couple of hours. At 8 days, 11 hours, 6 minutes mission elapsed time, this is Marshall, Space Lab Operations.
This is Mission Control Houston. We did have UHF air to ground with the flight deck during that Hawaii pass. No items of consequence exchanged between the Mission Control Center and the orbiter. We'll be LOS for about 40 minutes until we reacquire again through Botswana. 8 days, 11 hours, 7 minutes. This is Mission Control Houston.
This is Marshall Space Lab Operations, standing by now for reacquisition of signal through the tracking and data relay satellite in just under 1/2 minute.
And Space Lab, Marshall Ops, we are back with you here for 55 minutes. And Owen, we'd like to continue on the UHV. Over.
Okay, I've put the switch to the on position, and we have no lights on the UHV panel.
Roger, and then continue, Owen, with a start, UHV, enter, and then wait for about 10 minutes or so. You get a UHV stop or a ops off. Over.
Okay, we'll wait 10 minutes. We've got the UHV. We do have the ops light on at this time, Lubo.
Roger, we copied.
Hey, Marshall Ops Space Lab here for the 331 PI.
Reading you loud and clear, Byron.
Okay, Mike, just a quick debrief on your last run. We were able to form a bubble with, I'd say 110 or 120 degree contact angle on that undercut disc, so things look very promising. Over.
That's excellent news, Byron. Yeah, thank you.
We also got, unfortunately, we ran out of film on your cassette, but we have it on videotape. We stopped the bubble about 3 or 4 millimeters away from the front plate and waited about 2 minutes, and it jumped right across the gap and spread.
That sounds like an old electrostatic effect coming back.
Sure. I thought there weren't going to be any electrostatic effects in the FPM. Interesting when you've got a perspex, well, I guess it is, it's normal. Now we're trying to set up, the problem is the cylinder, Mike. We don't have a cylinder, we have different diameter end plates here, you realize.
I don't think that's quite so, Byron. If you have John Fadday's 30 millimeter end plate, that should be the same diameter as the disc that we've got on the front plate. Over.
Oh, it isn't. I can guarantee you that.
Okay, that's my engineering drawings are wrong.
You have is, well, yours is, I don't know, 50 millimeters?
I read 50 millimeters. Okay.
Oh, I'm guessing. I don't know. They don't provide us with a ruler up here, unfortunately.
Okay, Byron.
I know that it's substantially bigger than the 40 millimeter diameter end plate, the raised portion of the metal end plate. CPAC, are you getting data now?
That is affirmative.
Okay, Space Lab for Byron. I've talked with Isidoro, and he's very happy to go ahead with unequal end plates. Over.
Okay. You won't get a 90 degree contact angle.
Understood.
CPAC, are you getting data?
And Space Lab for Byron, one more. Isidoro reminds me that the intention of his experiment is to get the longest possible zone. Over.
Okay, we copy.
And Space Lab, we've got the master in hold, and we'll put it back in count before long. What volume? And Space Lab Marshall Ops for Owen.
Bill?
Okay, when you have an opportunity, we'd like you to turn to your flight data file and for experiment 356 and run page 356 Delta Tango -5. It's a power off for the experiment.
Oh. CPAC, are you getting data here? We ought to be coming up in several more minutes for the next run.
Roger, we confirm that you're in a preparation phase now. We are prepared to take data.
Hi, Bill.
Oh, and this is CPAC. How did the previous MPD ArcJet firings go?
Near as we can tell from here, which isn't too far, of course, it all went nominally. Everything on the displays was normal, just like the time before. So it's all running as smoothly as can be.
Roger, have you been able to detect optically the ESA 20 beam?
Negative. Even when it was darker, we were never able to detect that beam visually or with our cameras. So we find either, of course, the pressures have been running like they are right now, about 2.6 10 to the minus 6, and that pressure may be too low. And of course, we're in a different kind of a medium than the chamber, so perhaps that accounts for the fact that we can't see it.
Roger, but that is somewhat curious, isn't it?
If there is a BPD, it is certainly not very obvious up here. It's not like it is in a chamber.
That's right. We copied the same thing.
I was wondering if any of the other diagnostic instruments, including 19 Alpha, were seeing electron fluxes suggestive of BPD, even though we can't see it visually.
I think that's true, Owen. 19 was seeing at one time extensive. They were seeing extensive increases in the electron energy flux, exceeding the beam energy.
And Space Lab for Owen, when you have a chance to copy, or Byron.
Go ahead.
Yeah, the 01 PI has some interesting science that's going to be going on. Possibly you would want to do it. It has to do with shuttle glow, and she would like to have it done between hour 12 and hour 13:33 this evening before you go to bed. And what we'd like for you to do is to go get the Nikon camera that's stowed in stowage location Romeo 9 Papa, and also get a film controller. Repeat?
Had all the Nikons out in use for the whole flight, so is this a standard Nikon?
Yes, but I guess the key thing is you can use the Life Sciences color film. It's the ASA 160 film.
Been using that at a great rate.
Okay, and you can use another roll of that. And
I believe about 49 from.
Yeah, we copy. And also, there's two other opportunities. If someone on the red ship, when they get up, if they could do it sometime between 2:30 and 3:46.
If you're just suggesting that we photograph shuttle glow, we would probably do that anyway, and we've already been using ASA 400 film, of which we have a great deal still left for that purpose. Is that the objective?
Well, let me ask you, which do you think would show up the best, Owen? I'm going to let you use your judgment.
It's so light outside that I don't think we're going to be able to see anything further of shuttle glow. CPAC ops is on, incidentally. But I think the faster film would definitely be the best, and we do still have quite a bit of ASA 400, and we've got that loaded in the cameras. In fact, we have 3 Nikons, and they're each loaded with different kinds of film right now.
Okay, well, I think we'll just leave it to your call, Owen. You would know what's best to use.
Fine, Bill, we'll do that.
Okay, great.
Break, Marshal Ops, Space Lab here for the FPM PIs.
FPM.
Hey, we're growing a zone at a great rate. We now have 36 millimeter length, and it looks just super. Contact angle is about 90 on the top disc and about 70 on the bottom disc.
I copy. Space Lab for Byron.
I'll be with you in a minute, Mike. He can't get with you for a moment.
Okay, then.
Okay, Mike, go ahead. It's Byron here.
Okay, Byron, Isidoro sitting beside me says his ambition is 80 millimeters. Over.
Copy, 8080 is what he's looking for. We're at 51 now. The Congestion of the fluid, the tracers, is very visible even on the television screen, over.
I understand you can see the tracers even on TV. Great.
That's affirmative.
CPAC for Owen in Space Lab.
Right, Bill. I just noticed that we now do not have experiment ops on. Delta T is still at 0.
Roger, we are copying the same thing. We're not getting MPD firings.
I'm puzzled about that.
We are too. We're working it, Owen.
Get any firings at all?
No, we haven't gotten any firings at all. As a matter of fact, we're seeing DEP ready no.
I agree. It just switched to no down here also, or up here.
Owen, let's go ahead and shut down the experiment and try again at 37.
Go. Okay, we have an 80 millimeter column now.
Okay, Isidoro says go further with great enthusiasm.
Say again?
Can you dare to go a little further than that?
Can you go farther than 88?
Affirmative.
CPAC to Owen.
Hey, Bill.
Owen, we'd like to go ahead and do an ECOS crash recovery, which essentially turns off all the systems. The number on that is 02 George-2.
Say again the page. 02 what?
02 Golf-2.
Oh. Okay, Space Lab for the fluid physics PIs.
Fluid physics, go.
Okay, we have an 88.2 millimeter long column. The reservoir is at 61.4, and it looks pretty spectacular.
Would you repeat the length of the column?
Roger, 88.2.
88.2. Can I imagine that the shape of that zone is that it has a bulge close to the feed plate and a constriction close to the rear plate. Can you observe, and is that correct?